Hello, 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 check. Hello, 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 check. Hello, 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 check. Hello, hello, check. Hello, check. Hello,
hello, hello, hello, hello, hello, hello, hello, hello.
Hello.
Honorable dignitaries, learned delegates, respected teachers and students, a very good morning to one and all. We, your hosts, Adil,
And Anushi.
feel privileged to extend to you a very warm welcome to this National Symposium TROPMET 2022, Bhopal chapter jointly hosted by IMS and IISER Bhopal.
Bhopal, also known as the City of Lakes, is the capital of Madhya Pradesh and one of the cleanest cities in India. The city offers a true combination of the scenic beauty of historical and modern urban planning. Bhopal and its surrounding regions are home to several cultural and checkered heritage sites, including Buddhist monks at Sanchi and the rock shelter of Bhimbetka, both declared World Heritage Sites by UNESCO. One can also visit the Tropic of Cancer on the way to Sanchi. Other significant attractions in and around Bhopal include Fatehgarh Fort, Lakshmi Narayan Temple and the Museum of Man, and an open-air exhibit of replicas of different Indian tribal dwellings.
IISER Bhopal is a premier academic institute which was established in 2008 by the Ministry of Education, Government of India. The Earth and Environmental Science Department (EES) was established in 2014 as a minor course and then as a major course in 2016. The program encourages multidisciplinary approach by integrating physics, chemistry, biology, mathematics, geology and environmental sciences. It offers students a unique opportunity to build on their foundation in natural and engineering sciences to solve problems in the domain of EES.
TROPMET 2022 is a series of national conferences organized annually by the Indian Meteorological Society IMS. The IMS was established in 1957 and is a non-profit organization that promotes the advancement and dissemination of knowledge, especially in meteorology and related sciences. It has more than 3,500 life members from 100 or more research institutes, universities, user agencies, NGOs, and main industries. The objective of the society are dissemination of the knowledge of such sciences, both among the scientific workers and among the public, application of meteorology and allied sciences to various constructive human activities such as agriculture and land uses, irrigation and power development, navigation of sea and air, engineering and technology, medicine, public health, and others.
The IMS Bhopal chapter was established in 1997. The members are mainly from IMS and IISER Bhopal. The main objective of this chapter is to popularize meteorology and allied sciences along with their application in various human activities, mainly addressing the agricultural and water sectors. Now I would like to welcome Dr. Dhanya Lakshmi Pillai, Assistant Professor and Head of the Max Planck Partner Group at IISER Bhopal, on the dais.
Good morning, everyone. Welcome to TROPMET 22. It's my respected dignitaries, ladies and gentlemen. It is my pleasure to receive you here on our IISER Bhopal campus for the TROPMET 22, jointly organized by IISER Bhopal and IMS Bhopal. TROPMET, this year, we have an excellent theme that directly applies to the water and agriculture sectors. Over the next few days, we'll have an excellent opportunity to discuss and debate topics and share the knowledge related to the climate change. I'm so glad that we are joined by more than 300 participants across the nation this year. To kickstart our symposium, I invite our dignitaries to come on the dais and grace the occasion. So our dignitaries include Dr. Akhilesh Gupta, Secretary SERB, Professor Shiva Umapati, our Director, IISER Bhopal, Professor Sunil Kumar, Vice Chancellor, RGPV, Dr. Rupa Kumar Kohli, President IMS, Dr. R. Patnaik, Vice President IMS, and Dr. R. Balasubramaniam, Director, IMT Bhopal. So I invite all our dignitaries to come on the dais and grace the occasion. So now I invite Dr. Shubhi to come on the dais to felicitate. I also welcome Dr. Pankaj Kumar to come on dais. So now I invite Dr. Shubhi to give the bouquet to our dignitaries. So now I welcome Dr. Pankaj Kumar, convener of this meeting, for further welcome address. Thank you so much.
Good morning all, and very warm welcome. So it's very thrilled that we are seeing all this TROPMET happening again after 4 years of time in physical mode, fully physical mode. And it was overwhelming that we have received more than 600 abstracts, or nearly 600 abstracts, which was really very challenging for us to accommodate all in this system. So this year the TROPMET is organized, which focuses on weather and climate predictions, including applications in water and agriculture sector, and the climate variability naturally in space and time. Today's concern is the occurrence of climate change due to anthropogenic activity, and this anthropogenic activity become much more concerned when it is integrated with non-climatic factors, such as unequal access to resources, poverty, environmental conditions, and this all makes the things much more of concern. These changes are manifested in the increase of temperature and extreme weather events, such as floods, droughts, heat waves, severe cyclonic storms, and heavy precipitation events, such as which we are witnessing, such as in Pune, Bangalore, Chennai, even in Trivandrum, which was an event of in the mountainous region. Now we are witnessing in plain areas as well. These weather events need constant attention and monitoring to reduce their potential impact on society. Since observation stations are not available at every spatial point of interest, modeling efforts are required to help to assess the simulations as well as its prediction or projections. Also, processes studies are essential to understand the phenomena in greater depth. Keeping this in mind, TROPMET 2022 will make an effort to bring together climate scientists, hydrologists, agriculture scientists, local government bodies, academics, policymakers, and disaster and other related experts to discuss and share their information for the benefit of society at large. With this slight introduction by me and Dr. Dhania, I request all dignitaries to kindly lighten the lamp to start the ceremony formally.
Both of you are guests here, so you should start.
Now I would like to welcome Revati on the stage for the Saraswati Vandana.
सरस्वती नमस्तुभ्यं वरदे कामरूपिणी विद्यारम्भं करिष्यामि सिद्धिर्भवतु मे सदा सिद्धिर्भवतु मे सिद्धिर्भवतु मे सदा.
Now I invite Dr. D.R. Patnaik to say a few words about IMS Society.
Very good morning to all of you, respected dignitaries on the dais, Professor Sunil Kumar, Vice Chancellor, RGPB, Professor Siva Umapadi, Director IISER Bhopal, Dr. Akhilesh Gupta, Secretary SCRB, President IMS Dr. Rup Kumar Kohli, Convener TROPMET 22, Dr. Pankaj Kumar, all my colleagues from IMD, IITM, MOS institutions and other universities, DST, all, and also my respected fellows of IMS and also the viewer who are watching this online through YouTube. So it is great pleasure for IMS to hold this annual conference workshop after a gap of 2 years actually in physical mode. So there might have been some inconvenience also as we are used to the online pattern. But yes, we have overcome that one and we are starting this physical mode to conduct this type of workshop. Giving some background about the IMS, actually it is a long history already mentioned initially by the person from Bhopal chapters. But with respect to the TROPMET, actually started in 1992 in Ahmedabad. That was the first TROPMET. And so now we are completing 30 years. So in the 30 years, IMS means, because the whole idea about TROPMET means, yes, tropical meteorology, you know, it is a more important actually part. We are situated in tropics. So the weather is more challenging, it is not highly predictable compared to mid-latitudes. So a lot of research are to be done. That's why there are institutes also established, Indian Institute of Tropical Meteorology. So, and at the same time, it is not possible for the government agency like IMD, IITM to do everything. So there is a role of the society, and society has a specific objective actually, how to popularize the science of meteorology, also recognize the talent, giving awards, those who are doing contribution, and also popular lecture, printing, also activity-wise, IMS, lot of things. There are also now, because of the climate change, as you know already, it is a well-known fact, the severity of weather prediction is increasing, and as a consequence of that, there is a need of weather and climate services. And we have to reach out to each sector. Now all sectors are vulnerable now because of the climate change. Our focus here is of course agriculture and water, but there are other sectors also more vulnerable. Giving one small example, this year in February or March, there was a very sudden rise in temperature. As a result of that thing, means yes, rabi crops were there, but a lot of loss, huge loss was there. Simple rise in temperature in the second week of March. So that's the service is demanding, and there is a stress on water sector, agriculture sector, health sector. And IMS has a role, and we have to work together. So society can do the work easily compared to the department. So that's we have invited all the things here, public sector, private sector. Now they are coming in and sponsoring these events like energy, green energy. So we have to go for we have to migrate, we have to we have to adopt and we have to mitigate. So these are the issues where IMS can handle very well. And this is a unique platform actually, that here research students are there, they will get exposure. The experienced scientists also there, we will be hearing from them very excellent science, what are the present status, what are the different type of research work are being done. So they will be presenting, plenary talks are there, and also the disaster managers, operational forecasters. So this is a combination of all gathering where we will share our knowledge and exchange our idea, so that we will be able to provide a better services to the society to minimize the loss of life and property. And with this thing, I just wish a very successful TROPMET, and I thank all the Bhopal chapter, IMS, and also the all participants for making this event in a physical mode, and wish you all the best. Thank you.
Thank you, Dr. Patnaik. So, Dr. Patnaik is Vice President of IMS. Now I welcome Dr. Roop Kumar Kohli, the President of India Meteorological Society. And just to introduce Dr. Kohli has served nearly 13-14 years at WMO, World Meteorological Organization, Geneva, in different capacities. Especially he has his responsibilities at WMO included supporting the implementation of the World Climate Services Program, enhancing national capacities, coordinating regional and global networks of climate services providers, user license in climate-sensitive sectors, and research operation linkages. He has made significant contribution to the development of regional climate centers, RCCs, and regional and national climate outlook forums across the globe while he was at the WMO. And I know he's still in various committees of WMO even after retirement. Sir, please.
Thank you, Pankaj. Distinguished dignitaries on the dais, the chief guest of this inaugural function, Professor Sunil Kumar, Vice Chancellor, RGPV Bhopal. Guest of honor, Dr. Akhilesh Gupta, Secretary, Science and Engineering Research Board. Professor Shiva Umapati, Director, IISER Bhopal. Dr. D.R. Patnaik, Vice President, IMS. Dr. Pankaj Kumar, Chairman, IMS Bhopal Chapter and Convener of TROPMET 2022. Dr. R. Balasubramanian, Secretary, IMS Bhopal. Distinguished IMS Fellows and members, participants, students, ladies and gentlemen. My warm greetings to you all on the occasion of the inauguration of this flagship annual event of the IMS. At the outset, on behalf of the National Council of IMS, I convey our deep-felt gratitude to IISER Bhopal for agreeing to host this event in this beautiful city of Bhopal and the wonderful campus of IISER in collaboration with IMS Bhopal chapter. In particular, I admire the hard work put in by IISER faculty and students for spending many late night hours in the midst of their academic assignments to take care of each and every minute detail to make this event a grand success. Ever since TROPMET series was initiated 30 years ago, as my colleague Patnaik mentioned earlier in Ahmedabad, it has become a well-established event as one of the most important parts of the meteorological calendar of India. Interspersed by international versions of the event in the form of INTROMET. I gratefully acknowledge the strong support of the governments at central, state, and local levels, and also various institutions, including the private sector, in helping us to sustain the TROPMET uninterrupted over the last 30 years. After a gap of more than 2 years, due to the pandemic, we are now back with a face-to-face meeting, which I am sure will help us to reconnect with each other and enjoy a refreshing freedom from the monotony of virtual world in front of computer screens. Ladies and gentlemen, increasing societal resilience and agility to cope with the negative impacts as well as benefit from the windows of opportunity due to climate variability and change, requires an understanding of climate in terms of how it behaves and how its characteristics can fluctuate and change in space and time. In addition, it also needs an understanding of the sensitivity of people and their livelihoods to weather and climate, the impacts of extreme conditions and the associated risks. Availability of useful, reliable, and timely information and the ability to act on that information contribute to improved societal resilience in the face of climate variability and the capacity to adapt to the changing climate. As the old adage goes, climate is what you expect and weather is what you get. And it is imperative that we have a seamless approach to deal with weather and climate impacts on all our activities. It is therefore very apt that TROPMET 2022 chose its theme to cover advances in weather and climate prediction and projection, along with the applications in agriculture and water sectors. I'm also pleased that there is an overwhelming response to our sessions on applications of the energy sector, which attracted the attention of the private sector as well. Ladies and gentlemen, the IMS, through its nearly 4,000 members spread across about 30 local chapters and overseas, with their wide-ranging world-class expertise, is one of the best meteorological communities in the world. The IMS leadership in recent years has put in tremendous effort to enhance IMS activities, but I think there is still a lot of untapped potential in our membership, which needs our collective efforts and institutional support to be brought out in the best interests of the society. As climate change and its consequences to climate variability and weather extremes take center stage in global, national, and local level policy and risk management, I hope the TROPMET series will help us to take stock of our research advances, share knowledge and experiences, and raise awareness of the potential societal benefits of our constantly improving capabilities. I look forward to the impressive scientific program lined up in front of us over the next 4 days and wish the event a great success. Thank you. Jai Hind.
Thank you, sir, for this opening remark. And now I welcome Professor Shiva Amapati, Director, IISER Bhopal. He is an laser spectroscopist and was the chair of Department of Inorganic and Physical Chemistry and a professor of Instrumentation and Applied Physics at the IISc Bangalore. He is known for his studies of molecular dynamics using Raman spectroscopy and is a fellow of Royal Society of Chemistry and an elected fellow of Indian Academy of Sciences and also the National Academy of Sciences, India. The Council of Scientific and Industrial Research, the apex agency of Government of India, for scientific research awarded him Shanti Swarup Bhatnagar Award for Science and Technology. It is one of the highest Indian Science Award in 2004 for his contribution to chemical science. Sir, please.
Good morning to all of you, my friends and colleagues at the dais, Pankaj and the IMS members. Welcome to IISER Bhopal. It's a pleasure to see that finally we are all able to get together in a room, sit and have a conversation, which is much more necessary in the modern world in terms of communication rather than just doing online, because online has never been a very efficient mechanism of conversation in discussions particularly, and so I'm glad that we are all back together. Coming to the campus, you will see that it's about 200-acre campus. You would have noticed already that we maintain international class infrastructure, academic standards and research standards. And you will see a large number of students in the campus. You're welcome to go take a walk around the campus. It's extremely secure campus. You may or may not notice security, but you are being monitored, I can tell you that. because we have almost 500 to 700 women students and totally about 2,800 students in the campus. In the next few days, you will also see very young people. Our first year's admissions are starting day after tomorrow, and so you will have about 380 students, and their parents will be lugging between the main gate and the hostel. And I hope it doesn't disturb your activity, but it'll be crowded. There'll be a lot of running around in the campus, and so it'll be quite busy. But of course, it shouldn't interfere with what's happening in this hall. But in terms of other areas, you will see a large number of people. I'm just keeping you informed so that you know why there is a crowd. Because they're coming first time. They've never been to this campus before. They're all 17, 18-year-old children, and they come with their parents. So everybody wants to know about the campus. They will walk around the campus to figure out what's going on. And you can be part of that event of inaugurating the first years in the campus. So I hope you enjoy your stay in the conference. Particularly, I want to tell the students that one of the things we always encourage in IISER Bhopal is that we would like students to participate in discussions more in terms of any conferences that we organize. We always advise the students that this is the right time to ask the question, because that's the time to learn. Because being shy is only puts you at a disadvantage in terms of asking the right questions and learning what you don't know. Coming to IMS, I'm so glad to see that I'm not an expert in meteorology or even atmospheric sciences, but I'm of course a public routinely uses weather forecast. And the unfortunate thing is that I have to apologize. I'm not sure whether you have an Indian portal where I can download an app and monitor Indian weather. I have downloaded the BBC weather and the other apps because we need to monitor where we are traveling, and so we need to know. And I'm aware of the fact that our resolutions of monitoring is not at high standards, and I think people like you should probably push this to the next level with the government, because I can tell you one thing, being part of the science and technology policy, where Dr. Akhilesh Gupta was the coordinator of this science and technology for Government of India. The discussions were no holds barred. So there was open discussions about the evaluation of what we have achieved so far in this country, what we need to achieve in the future. And there is nothing about criticism. It is about self-introspection of what we have done in 20, 30 years, and therefore where we should go. Because the demographic changes are very large, and when the demographic changes are happening, the demands of the country change. And that is something that we should take into account. So that's what we did in the science and technology policy discussions. I think IMS probably should do something similar to introspect to see what have we done in the last 20, 30 years, and where should we be going in the next 20 years. And the importance of yours, in addition to encouraging IMS research, IMS fellows, your advice to the government is extremely important. And that has to be unbiased, open, of international standards. And I hope these deliberations that happen in the next 3 days culminate into some sort of a white paper of recommendations to the government, which then you can take it up forward and make sure that we move into the next level. So with this, I wish you all the best. Enjoy your conference, and please feel free to go around the campus and enjoy the stay. Thank you.
Thank you, sir, for this address. And one of the key point for organizing this conference on the physical mode was exactly what he said, is that to make sure the students get opportunity to interact with the seniors. Otherwise, online mode, you don't get this opportunity. So you have good opportunity. I know a lot of students are sitting upstairs if they're listening us, so please take care of this. Now, I invite our guest of honor, Dr. Akhilesh Gupta. Dr. Akhilesh Gupta is a senior advisor at the Department of Science and Technology, TST, and recently assumed the charge of Secretary of Science and Engineering Research Board, Government of India. Dr. Gupta has, to his credit, over 200 research articles in national and international journals, proceedings, and he is the editor of 5 books and author of 350 articles and nearly 100 reports. He is fellow of Indian National Academy of Engineering, the Indian Meteorological Society, and the Association of Agro-Meteorological Meteorologists. Dr. Gupta currently heads the Policy, Coordination, and Program Management Division, and it's overall in charge of 5 national missions of DST. Dr. Gupta has been one of the author of Indian National Action Plan of Climate Change and head of the Secretariat, which drafts India New Science, Technology, and Innovation Policy, which is under construction, finalization. So, welcome, sir, please.
Thank you so much, Dr. Pankaj. The chief guest of today's event, Professor Sunil Kumar, the Vice Chancellor of IGGG, Professor Shiva Umakati, Director of IISER Bhopal, Dr. Rup Kumar Kohli, IMS President, Dr. Patnaik, Dr. Galasubramaniam, Dr. Pankaj Kumar, some of the very distinguished guests who are here. I must name them: Dr. Kalachand Sen, Director of our Vadia Institute, Dr. Kishi Joshi, the veteran of IMS who has so much of memory of IMS, Dr. M.S. Narayanan is here, Dr. Mukul Tiwari from IBM, Dr. Raj, and many others who are here. I may not be able to name all of them. A very good morning to everybody. Let me at the outset thank the organizers, the Indian Meteorological Society and the local chapter and Director IISER Bhopal here for having invited me to this event. As was mentioned, that this is the 30th year of TROPMET. It started in '92 from Ahmedabad, and this journey continued over time. And we had several international and national levels. But also, besides TROPMET, we have several other, the consensus and events. I become very emotional because of my long association with IMS. And the only IMS lifetime member who has been in the National Council for 12 years. 2 terms as Joint Secretary, 2 terms as Secretary, 1 term as member, and 1 term as President. These 12 years have been kind of long, deep association, and in these 12 years, we organize as many as 21 events across the country, all can TROPMET, INTROMET, and other things. And so I recall that those days of intense work that we did. But TROPMET is 30 years old, but IMS is much older. IMS was established in 1966 in the Calcutta session of Indian Science Congress. So IMS is 66 years old now. And when it was in 1966, 66 years old, when IMS was set up, there was no meteorology institution in the country except IND. And so it is a very common phrase that you see that IMS is IND and IND is IMS. In fact, I am the first secretary outside IND. So the IMS, in fact, expanded its network beyond IND only in last 20 years or so. I remember when I took over as Joint Secretary of IISER, there were only 620 members. And now we have 4,000 members. And most of those 600 members were meteorologists. And now we see the diversification, hydrologists, the geologists, the disaster managers, and all kind of diversified, members are there from IISER. So when to look at the progress in meteorology has made in last 66 years, since the 1966. Just imagine one institution on meteorology in 1966 and IMS was set up. And today there are 650 institutions in meteorology where meteorology is taught or research. Such a big expansion that has taken place in meteorology over the time. This is the time, I think, as Dr. Umakati mentioned, I definitely agree with him. This is the high time that we work on a national policy on meteorology. Why it is required now? It is required because, let me go and refer to the IPCC report that we had, which was out last year, the 6th IPCC report. The outcomes are very clear. Now in next 20 years, the temperatures are going to exceed 1.5 degrees centigrade from the present level. And that is going to change all the entire, kind of socio-economic, it is going to make a big impact on socio-economic things. So temperatures, there are, in fact, it is estimated that if temperature exceed 2 degrees centigrade, it's going to be a tipping point, and it's going to have severe consequence on two areas: the human health and agriculture. These are the two areas going to be impacted severely. You will exceed the limit of tolerance for the human being. Temperature goes 2 degrees centigrade more. But then the bigger impact is going to be on the extreme events. Extreme events are going to be more variable, more unpredictable, more intense, more frequent, and of longer duration. India has a high population density, and we have so much of poverty. This high impact event that is going to increase over time will in fact put so much of direct impact on the population. And we do not have enough adaptive capacity. And therefore the development and adaptation will have, there is a dichotomy between development and adaptation. If you have high development, you will have more coping capacity to adapt. India is going to face this kind of dilemma or the contradictions. We need to, so role of meteorology becomes very important. The meteorology is going to be the major driver of economy in the country. And therefore, we need better system, observing system, better prediction system, better warning system. And therefore, this is the big challenge. So I'm not going to go into detail because I have my next presentation after this event, so I'll elaborate there. But what we are planning is now, in fact, the Ministry of Earth Sciences and DST join hand, and we have now set up a National Climate Research Consortium. This consortium is going to address together the major climate issues, and we in fact have already set up a National Climate Research Agenda team, and many of the members of the agenda team here. We are going to organize a national conclave shortly to discuss this agenda. And as done in US and other advanced countries, that this agenda cannot be on paper. This has to translate into action. And we already have strategized how do we translate that the agenda that is going to be prepared will be funded by funding agencies. And therefore, this is going to be, and most of these agenda team, there are 20 team members, they are all young. We have not get anybody more than 60 years in that team. Because, when I say that you have Agenda 2030, so at least those who are members of this agenda team should survive up to 2030 or beyond. It cannot be people, generally, any metrology thing or anything, we will choose, those people 70 and above. They have better wisdom. I think this is the time when we focus on young people. So we have so much planned for young people, not just at the level of planners, but also at the level of beneficiary. I would conclude here and say that we have so much of challenges to come, to meet, and therefore there is a last point I would say that we need to work together. There is no option left. We have worked enough in silos. So we need to work together for the national cause and make metrology a real driver for the future economy. We need to give leadership. I know young people are all looking towards us, not just in terms of funding, but also in terms of plan and direction. I think we need a good direction, and we need a very decisive and dynamic leadership in this area. I think I would end it. Thank you very much.
Thank you very much, sir, for this highly motivational and inspirational talk. And now I invite Dr. Ram Kumar Giri, Secretary IMS, to announce some awards which we are giving from the IMS Society. And I do hope that we have all these awardees around.
Scientist award for best paper.
So they are here or not? These awardees.
Oh, hey.
Yeah, good morning. Thank you very much, Dr. Pankaj. Now, actually, it is my pleasure to announce the IMS awards at different disciplines. Then, first award in this series is Young Scientist Award for the best paper publication on tropical metallurgy. So it is in the recognition of this IMS Young Scientist Award. I request S. Indra Rani, please come on the stage. Second, now second award for best paper published on monsoon research. It is formally B.N. Desai Award, and in this series I will call on the stage Soumya Samanta P. Muruguval. Kindly come on the stage. And the third award for the best paper published on the weather and climate services. This is formerly Bhavanacharya Award, and this award goes to Rishi Kumar Gangwar and Pradeep Kumar Thaplial.
Actually, he has not come. So
Okay.
I will be collecting on
You
behalf
just please collect.
Yeah, please. Rishi Gangwar ji is collecting on behalf of him. And the last for the best paper published on climate science and climate change, Professor D.V. Bhaskara Rao Award. And this award goes to Madam Kamalji Tre and his team. She is not there on behalf of her. May I can
Okay, perfect.
Okay, sorry, just forgot the award carry also the cash prize, so that will be transferred online. Okay.
Now I'd like to request all the dignitaries to release the souvenirs cum abstract book.
Now for the felicitation of our dignitaries, first I would like to request Professor Siva Umapati to felicitate Dr. Akhilesh Gupta. Now I request Dr. Roop Kumar Kohli to felicitate Professor Sunil Kumar. Now I request Dr. D.R. Patnaik to felicitate Dr. Roop Kumar. Now I request Dr. Pankaj Kumar to felicitate Dr. D.R. Patnaik. Now I request Dr. Sanjeev Kumar Jha to felicitate Dr. Pankaj Kumar. Now I request Dr. Sanjeev Kumar Jha to felicitate Dr. R. Balasubramanian.
Next up, we have a short video message by Dr. M. Ravichandran. He's the Secretary of Ministry of Earth Sciences. He was the Director at NCPOR, Goa. He worked as a scientist in Indian Institute of Tropical Meteorology, Pune. He has also worked in National Institute of Ocean Technology in Chennai and at Indian National Center for Ocean Information Services in Hyderabad before joining NCPOR. Dr. M. Ravichandran has been selected for the MOES National Award for Excellence in Polar and Ocean Research for his contributions to the Indian Agro Project and ocean modeling.
Thank
So we thank him for his address. He really wanted to be here, but unfortunately, because of some pressing things, he was not here. With this, we come to the address of our chief guest, Professor Sunil Kumar sir from Rajiv Gandhi Pradhyogiki Vishwavidyalaya, locally known as RGVP, the State University of Technology of Madhya Pradesh, India. He has also served as an additional secretary in the Department of Technical Education. He has also served as the Secretary of Admission and Fee Regulatory Committee, Government of Madhya Pradesh. He has more than 50 research papers in various international journals. He has been instrumental in designing various social sector schemes in the field of skill development. He is one of the governing board member of NITTER Bhopal, IIIT, and ITM University Gwalior. He is also chairman of Central Regional Subcommittee of All India Council for Technical Education, dealing with technical education of Madhya Pradesh, Chhattisgarh, and Gujarat. He is a member of various committees formed by the state and central government, member of various selection committees for selection of high-level key officials and accommodations. So I request you, sir, to give your address.
Honorable Siva Umapati ji, Director of IISER. Today's guest of honor, Dr. Avinash Gupta ji, Dr. Patnaik, Dr. Kohli, Dr. Balasubramaniam ji, and the convener of this program, Dr. Pankaj Kumar ji, and all the participants of TROPMET 2022. Looking at your serious faces, I am really sure that you are going to have some serious discussions. That is one thing. That is one thing I am really sure. And the reason being, I remember my good old days with IIT Delhi, when my professor said me or told me that we are going to have one modeling of air pollution at the crossings of Delhi by assuming rows of vehicles as a line source of pollution, and that's why you should go for studying numerical methods in atmospheric sciences. I attended the course for 1 week and I withdrew from the whole project. On that very day, I understood that this is not my cup of tea. And this is a great reality that atmosphere is going to change. There is no doubt about that. Atmosphere or climatic conditions cannot be static at all. At least at one thing I can very sure that at IISER Bhopal it is quite static. And reasons are quite obvious. Professor Umapati is there, so. But in the rest of the world, you will feel like it that climatic conditions cannot be kept static. That is against any logic or any mechanics or any laws of sciences. But the point of concern is that whatever is changing, the parameters which are changing, average parameters which are changing, that should not be at such level which are not reversible. That's the point of concern. If you feel like it, there will be no cyclone, it's not possible. If you feel like there will be no excessive rains, it's not possible. If you feel like it, there will be no excessive heat, it's not possible. If you feel like it, there will be no excessive cold, it's not possible at all, sir. It is bound to happen. What is the point of concern? That over the years, we have used this word like we are using our first law of thermodynamics. Do you know what is first law of thermodynamics? Basically, I am a person of thermodynamics, so I know it. That is law of energy conservation also. This suggests that energy can be changed from one form to another form. It means no need to worry. The whole amount of energy is fixed.
So at whatever time you want to change one energy from one form to another, you can change it. So what's the problem with this? But as soon as you go through the second law of thermodynamics, which talks about entropy of the universe, and which talks about the heat death of the universe, then it looks like that something serious is happening and we are not using our energy in a very sustainable way. We are utilizing more energy which we can afford, and that's why we are heading towards slow death. That's the point of concern. And as Professor Avinash Gupta was saying correctly, as I have come to know that 1.5 degree temperature rise is bound to happen within 6 years. If we are using energy at this level, then this temperature rise will happen within 6 years. And there is thought process that then certain things will be irreversible. So this is the point of concern. So I really appreciate the number of papers which have been received under TROPMET 2022, conveners saying that almost 600 papers have been received in this field. So it means a lot of things are going on in this direction. Otherwise, what happens whenever we work in isolation or in silos, we feel like nothing is happening in the field of meteorology. But when I attend this kind of conference, then I come to know a lot of things are going on in the field of meteorology. So naturally, you people are really concerned about the whole concept. And as I have come to know that more and more streams of sciences or engineering and technology have been merged, and the work and the projects have been undertaken by this society. So this is really a good sign. Reason being that no discipline can survive unless otherwise it is multidisciplinary. Because problems are of multidisciplinary nature, and you cannot serve the purpose working in isolation. So I really appreciate this gesture of Professor Avinash Gupta ji, Dr. Avinash Gupta ji in particular, wherein he says that he's pushing that person of other disciplines should also join this particular society and they should contribute in this field. And naturally, this is my personal feeling that India as a country can contribute much more as compared to other countries in the field of meteorology. The reason being, we feel that we are facing problems, all sort of problems, and we have all kind of weathers in India. So naturally, you have a live lab in India itself, wherein you can experiment and you can do wonders for the society. I still remember the good old days, almost 20-30 years ago, जब आपका रेडियो ये बोलता था ना कल पानी बरसेगा, तो पानी we were very sure कि कल पानी नहीं बरसेगा. And the reason being the whole dynamics are so chaotic that when you predict by certain model that tomorrow rain is going to take place, it is not going to. The reason being that certain parameters is being missed. But recently I have seen that predictions are quite accurate, quite fair, much better, and you can rely on certain predictions. But in old days, it was never used to be that way. And one can be very sure if you are predicting tomorrow it will rain, it is not going to rain. So, so Dr. Akhilesh Gupta ji, I was telling his name wrongly. So Dr. Akhilesh Gupta ji, who was telling that he was pioneer person as far as this particular society is concerned. He served this society almost for 12 years. And he was remembering the good old days when he was joint secretary, then president, member, and with the society. And during his time, this society flourished, and now there are more than 4,000 members. So at this juncture, I just wish my all best wishes to this particular society. So you people are there, and I am really very happy that the way this particular society is working and the kind of work you are doing, and that's why we are getting much more accurate results as far as the weather predictions are concerned. But one thing is very sure, that issue is serious, definitely, but it is in our own hand actually. If you will start using energy in a very rational manner, Mother Earth is quite generous to take care of each and everyone. So it's up to you in what way you treat your Mother Earth. Thank you very much.
Thank you, sir, for this inspirational and with very interesting examples. And we thank you again for coming and addressing this audience. Now I invite Dr. Bala Subramaniam to give vote of thanks.
Thank you, sir. Good morning to all. So it is my great privilege to propose the vote of thanks during the inaugural session of the TROPMET 2022 National Symposium. To begin with, I am extremely thankful to Professor Sunil Kumar, Honorable Vice Chancellor, Rajiv Gandhi Praudhyogiki Vishwavidyalaya, and then who has kindly considered to grace the inaugural function as the chief guest and also addressing our August gathering. I am also highly grateful to Dr. Alkesh Gupta, Secretary, Science and Education Research Board, New Delhi, for his gracious consent to be the guest of honor and also for addressing the enthusiastic gathering. My sincere thanks are also due to Professor Siva Umapati, Director, Indian Institute of Science, Education and Research, Bhopal campus, for addressing the delegates and granting necessary permission to host this event in the sprawling campus. Dr. Rupakumar Kohli, President, Indian Meteorological Society and former Chief, World Climate Applications and Services Division, WMO, has been a multifaceted personality, and I am sure that Indian Meteorological Society will flourish further under his presidency. I am highly thankful to him for his address. Interaction with these distinguished personalities prior to this day have helped us to define the event in its present form and have given us the necessary encouragement for the entire course of action. I am also thankful to Dr. M. Mahapatra, Director General of Meteorology, IMD, and then Dr. M. Ravichandran for their address, Secretary, Ministry of Earth Sciences, for their support and granting necessary permission to organize this TROPMET 2022 National Symposium. Sincere thanks are also due to Drs. Pankaj Kumar, convener of TROPMET 2022, and Dr. D.R. Patnaik, Vice President, Indian Meteorological Society, for welcoming and addressing the delegates. Dignitaries and experts, to name a few, Dr. P.C. Joshi sir, Dr. Ravi Nanjundia sir, Dr. Nikul and then Dr. V.K. Segal, and also speakers of various sessions who have gathered here from across the country amidst difficulties and inclement weather. My heartfelt gratitude goes to them. I am thankful to the faculties of IISER, scientists and officers from various MOES organizations, ICAR, and various universities for taking part in the TROPMET who make the event successful. The local organizing committee, particularly just my sincere thanks goes to the student force who have toiled round the clock for each and every aspect and made us comfortable to attend the event. Deep sense of gratitude is due to them. I am also thankful to the media friends for taking part in the event and for their wider coverage. So I thank every member of this audience present here for this inaugural ceremony. Thank you. Thank you, Jai Hind.
So before we break for a high tea outside, I just have one or two quick announcement, which I will just read for the audience so that we know how this workshop is going to be conducted in the next 4 days. So the most important point usually you ask for is Wi-Fi, food and lodging, etc. This all will be information you will get on the help desk. For the next 4 days, we have planned very interesting plenary, keynote, invited lectures, as well as oral and lightning talks. Lightning talks usually for 2-3 minutes. So good poster which we have selected to demonstrate by the participants to the audience so that you force them to go and look at their posters, to your posters. Then poster presentations, this will be done outside. We have a very nice garden outside where this poster presentation as well as the lunch and dinner will be served. All these sessions are organized in different parallel sessions in 3 different halls. One is this auditorium, and then hall 1 and hall 2 on the first floor, and some sessions in 1 or 2 boardrooms, but that will be a very small gathering for short group of people for some discussions. We have made arrangement for the lunch and dinner for all 4 days in the VH, and breakfast will be served into your respective guest houses. If you have still not registered, you can do, and also you can do it online also. There's a provision we have. There are student volunteer present around. You can contact them for any queries, concern, or help. So immediately after this tea break, we will be resuming in the same hall for the plenary talk, which will be given by Dr. Akhilesh Gupta sir, and this session will be chaired by Dr. Kalachin Sen sir. So I also, just to mention that we have some other dignitaries who are sitting in the hall. Dr. R. Krishnan sir, Director IITM, thankful to Joshi Saab already for being here, Sen sir, and many more around to make this event successful. I know there are so many dignitaries who are coming who could not make to this event on this particular day. Maybe the Secretary Saab will also come, and the ISRO SAC Director, Space Application Director, will also be one of the dignitaries. He will be speaking, giving plenary talk on 2nd December. And there are 2-3 more senior colleagues who will be coming and speaking around. So it is really going to, we have Dr. Rajiv Mahajan Saab also from CRBC, Advisor Government of India. So we will be having a lot of people, senior colleagues, which especially I'm talking to students right now, that you should try to interact with these people and express yourselves and introduce yourself. So with this, I thank you all again, and we break for this session, and I invite you all for a high tea outside. So just one, sorry, this one announcement, please.
So all the participants are requested to submit their presentations to the following email ID with the following format.
Yes, so thank you, sir, for reminding me. So we stand for national anthem before we disperse. Start. Something to play? Do you have something to play? No? Okay. Janagadamana Adinayaka Jaya He Bharat Let's take them, right?
हेलो 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 क्या आपके पास कितने पॉइंटर हैं?
यहाँ बाहर एक भी नहीं है।
हेलो 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 वैभव वैभव अभी वो जाकर पीछे बोलो, इससे आवाज़ आ रही है, यहाँ लगा के, यहाँ लगा के।
चलो मैं अभी ऑडिटोरियम में हूँ, तो एक काम कर, वहाँ लॉन से बोलिए एक रिफ्रेश, लॉन में रिफ्रेशमेंट के लिए डब्बा ले आ। एक मिनट। हेलो 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 आप लोगों का आ रहा है? मतलब पीछे, हाँ हल्का हल्का आ रहा है इधर। हेलो 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 ठीक है अब। We will be starting with the plenary session soon, so kindly be seated. We will now begin with the first plenary talk of the day. So I would like to invite the chair, Dr. Kalachand Sen, who is the director of Wadia Institute of Himalayan Geology, on the dais.
A very good morning. All of us are eagerly waiting to listen to Dr. Akhilesh Gupta ji, who is the Secretary, ACRB, as well as Senior Advisor to Department of Science and Technology, Government of India. I know him personally since long, and you also have seen him a very dynamic, enthusiastic, and pro-scientist human being. And under his leadership and guidance, a lot of programs and initiatives are there into the ACRB. Many of you must have submitted your programs, proposals, and he looks forward, the young people, young scientists, researchers, faculties, so that they can come up to address some of the societal challenges, provide some sort of solutions, what country is looking for the disaster resilient, climate adaptable future. So I'll not take much time. May I request Dr. Akhilesh Gupta ji to share his thoughts, views on very important topic today we have chosen, and he will be talking on climate research in India, Vision 2030 and beyond. Dr. Gupta ji.
Thank you so much, Dr. Kalachan. Very good morning to all of you. I think the introduction to my talk I have already given in the morning session. And so I will build upon what I said in the morning. The motivation for this came from the fact that India is now at a crucial juncture where we need to upscale climate research. And how do we do it? What kind of issues are there? And how do we bring institutions and individuals together is the idea behind this talk. I am not an active scientist today, so please bear with me, because I am now last 1.5 decades I have been working at the policy level. But this is a very unique opportunity when you turn from researcher to administrator, then you know the nuances of all sector, and that's why I always say, and as Dr. Kalachan mentioned, that my focus has always been the young people. Now let me see that India, in fact, when IPCC started, first assessment report in 1990 to the fifth assessment and also the sixth now. And so we have been taking initiative at the national level through various ways. I mean, whether it is the field experiment or the taking research initiative, all that you see, in different stages of, in every assessment report, we have responded to this thing. In fact, both Ministry of Earth Sciences and DST have been, in fact, initiating research programs in their own way. I'm not going to elaborate, and since this is the action that DST has taken, since I was heading these two missions, I will elaborate a bit on this thing. So when, in fact, this is an interesting coincidence that when the third the fourth assessment report came in 2007, and there was a committee at the national level, the INTAC committee of cabinet headed by Prime Minister, decided to have a national action plan on climate change. And I happened to be at that time advisor to Minister of Science and Technology. People believe that climate change is the subject being driven by Ministry of Environment and Forest. But the National Action Plan was drafted by Office of Minister of Science and Technology. This is a unique kind of thing. And this was required in very record time. We had launched 8 national missions. 2 of them were given to DST. And it came to DST at a very crucial point. When DST, Ministry of Earth Sciences, was formed in 2006, and DST had given everything to Ministry of Earth Sciences, including IND, NCLR, IITM, all initiatives. And DST was left with no institution of its own. And then at that time you were supposed to coordinate. I was the only meteorologist in the entire DST. And I also was, kind of having the Ministry of Earth Sciences Secretary was asking me to come to Earth Science, but somehow I remained. So that the famous movie where somebody comes from the other planet and remains here, doesn't go back. So I am the person who remained in the DST, did not go back to Earth Science. Anyway, so these are several initiatives that we took in the last 1 decade. The missions, under 2 missions, a large number of network of institutions were supported, and see, these are all center excellence that we supported in diverse areas of science, major R&D programs, network programs, and so on. So this is the kind of, if you look at, and we also set up the state's climate change centers. In fact, Loken Thakkar is here, one of the centers is here in Government Environment here in Bhopal. So we set up something like 25 state climate change centers. So this is the summary that we supported 170, 360 institutions, 1,400 scientists. By the way, this is the statement that I gave in the morning. We have 650 institutions in the country working in the area of climate and related areas, teaching and research. And you know how many scientists? 4,000 plus scientists in the country, nearly 1,800 students in the research area, they work for meteorology. This is a huge network that we have. And we, in fact, targeted that you will be able to, by end of this mission, will be able to support almost every individual Lilliquat and every institution in the country. Now, some of the important outcomes that our industry, we did, this is the, now you can say the vulnerability assessment has been done by many states, and this is what is new about it. This is a very different vulnerability assessment that we did. It is based on AR5 definition. So earlier, the vulnerability as definitions were different. We used that and did this vulnerability for 29 states of the country and 690 districts of the country. And this is a result that shows that Jharkhand is the most vulnerable state. And there are 8 vulnerable states, that's in Jharkhand, Mizoram, Odisha, Chhattisgarh, Assam, Bihar, Arunachal, and West Bengal. This is the entire eastern belt. And incidentally or coincidentally, these states where the vulnerability is high are also the poor state where the GDP is low and poverty is high. This is a district level. You can entire this box you can see is highly vulnerable to climate change. Now, this is the work that one of our PIs had done. That due to good literacy and conversion rates of marginalized group in the country, and also decrease in the child population due to better birth control, the social vulnerability is decreasing. Physical vulnerability is increasing, but social vulnerability is actually decreasing. this is the kind of contradiction that we will face, where we need to work as a society to see that when the climate change increases, the physical vulnerability will increase, whereas with better development, social responsibility will increase. Now, in fact, the National Mission for Himalayan Ecosystem, Dr. Kalachand is here, who has been leading the Center for Glaciology at Wadia Institute. We did a lot of work in glaciology, and you remember those IPCC third report where the glaciology has been very badly portrayed by IPCC report, where it says that some of the especially some of the glaciers like Gangotri glaciers are like to vanish in few years. Thereafter, in fact, DST had worked very extensively with the institution, created a network, SARB, in fact, work on a glaciology, ENC, and a lot of work has been done in this area. Now we have clarity as to what is the glaciology research in the country. So look at on an average, putting all put together, there is no doubt that glaciers are retreating. No doubt. Nobody can deny that glaciers are retreating. Across the Himalayan range, the glaciers are retreating. And the average rate of retreat is 5 to 20 meters per year. This is the rate but there is nothing abnormal trend in recent years. In fact, there was in between time when some of the glaciers like Gangotri glacier had receded very fast, but now it got stabilized. The glaciers are losing mass at the rate of 6 gigaton per annum, which is 0.2% per year. What is important is that the large glaciers with the area more than 10 kilometers square are getting less impacted compared to the small glaciers where the area is less than. And this is the statisticity. So nearly 66% of the total number of glaciers have areas less than 1 kilometer square. And they occupy only 4% of the total volume, total area, and 12% of the ice volume. So please understand that, don't go by number. This is and it is just 3% of the total number that have area more than 10 kilometers square, but this occupies 65% of the ice and 45% of the area. Now, this is the kind of data that we get. So, although glaciers are receding, numbers, in fact, many of the glaciers are vanishing, and there is some kind of glaciers are joining. So, fragmentation and joining taking place, but then these are mostly happening for the small glaciers. For large glaciers, the trend is very different. Now, another study that we took up as a part of the mission is the aerosol study, and here it really clearly shows that we have a lot of good results. And one of the results is that in the high aerosol buildup, during dry spell, makes dry spell drier, and following wet spell become wetter. This is, you can understand the loading, the aerosol loading that is taking place is making so much of variability in terms of rainfall. Aerosol cloud influence also, I think this is a known property, the aerosol cloud interaction taking place over the Indian region, and we see that this kind of the soluble organic aerosol is making a lot of impact on the non-conductive system, and also show negative ACI over the continental region. This is the data that our people at our BHU center has done, that you can see that the daily diurnal temperature range is actually decreasing over most of the country, or more so in some of the area like northeast and central India, where the diurnal change is taking. And that is understand that the trend in the temperature is that minimum temperature is rising faster than the maximum temperature, and therefore the range is decreasing. Now, this is the work that is needed from the point of view. The entire world is now saying that if the temperature increases beyond a limit, what is the option to the world? So the policy people are debating that we must have two options available to us. One is the carbon removal, and other one is the geoengineering. And these two, so in DST had worked on these two very extensively. Our people in IISc Bangalore work and seen that what is the impact of injecting the aerosol at the stratosphere to geoengineering. And then we see that, it's very interesting. So impact on ITCG is that, the ITCG sit to the other hemisphere once you inject in this hemisphere. So this is interesting, showing that the convections are going to be impacted seriously when you are going to inject the aerosol at the stratosphere level. Also, the monsoon rainfall, again showing that it is increasing, decreasing in the hemisphere of injection and increasing in the other hemisphere. So this is another kind of data shows that geoengineering need to be carefully used for the country. Same thing is the regional impact on monsoon in the thing. Of course, this is mostly in the RCK 8.5 scenario. Also showing that there is going to be persistent drought over India if we use the aerosol injection in the hemisphere in that particular. That's a bad thing. So, why I am showing this, that when this the issue of whether the world can use in the worst scenario this geoengineering, what impact it will have on India. In the rest of the world, the impact is not very clearly seen. But in Indian region, three things are going to be impacted. The convection is going to decrease, the monsoon is going to have so much impact, and also the general rainfall, overall rainfall is going to decrease over the country. Of course, many studies have been done. This is the one study I want to mention, just published in Science. We have, that El Nino droughts and non-El Nino floods. These are all known, that is it. But we have, that we have droughts during El Nino, non-El Nino, and also drought during El Nino. Both are important. So this is a study that is given. Drought in non-El Nino and also drought in El Nino. So all this, if you this study has been done by Venu and others, and is saying that in the El Nino drought, the pattern of rainfall is very different from the El Nino drought. These are like the two diverse kind of issues that we discuss. So, how the build-up of rainfall takes place from the June to September is very different in these two conditions. Now, coming to the key issue, that when the sixth report of assessment came, as I mentioned in the morning, we have the next 20 years going to be very important, because then temperature, if nothing major is done in terms of emission reduction, going to exceed 1.5 degrees centigrade. And if it exceeds 2 degrees centigrade, then heat extreme would reach a critical tolerance limit. And that is, and especially for agriculture and health, especially the Rabi is going to be impacted severely, if not Kharif, in the agriculture. But overall agriculture is going to be impacted, although there is going to be greater agriculture greening take place, but then that will be offset by the temperature rise. And health is one area where you reach a limit where the humans cannot tolerate that temperature. More rainfall, more associated, these are all known that we are going to have in future, but some of them will reach a limit where it will be very difficult to do. Now there is going to be serious food, water, energy and health security in the future. Country of this size with so much of diversity and so much of agriculture gradient, we will have issues related to all these areas in future, and therefore we need to have a strategy to address these insecurities. This is the AR6 major deviations on the earlier thing, that the interdependence of climate, ecosystem and biodiversity and human society. So therefore the impact of climate change and interlinkage of climate change with the social issues are the one. So therefore the all non-climatic global trends in terms of biodiversity loss, overall unsustainable consumption of natural resources, land and ecosystem degradation, urbanization, all these are the new areas that we need to address. Now, as I mentioned in the morning, that this is the first time that DST and MOES had joined hands and set up a national consortium on climate research. And the idea is that Earth Sciences does most of the research intramural. IITM, INSEAD, ANDI are the intramural research institutions where the funding is done by the government direct to the institution. But the larger community outside these three institutions remain unaddressed and unsupported. And that is where DST can pitch in. So DST and MOES put together can cover the entire range of institutions in the country. So this is the idea that we thought that let these two ministries, the government, work together and address jointly all the research issues. In fact, so we set up a national climate research agenda for 2030 and beyond. This is the why agenda, because we need to take the climate research into the future of how we address this thing in future. And this is the dynamic time when we have so much of issues. Now what we did, as I said in the morning, normally when you ask, when Dr. Ravichandran and myself we discuss how do we set up this agenda team, then Dr. Ravichandran was suggesting that we should work with young people. So it was his suggestion. We set up a young team for drafting this national agenda. Look at, so that I'll count. So these are the 7 areas that have been identified as major climate research areas for the India. Climate modeling, monsoons, extreme events, aerosol, urban climate, glaciology, and the Himalayan ecosystem area. These 7 areas cover the entire gamut of climate research issues in the country. Now this is the team that I see. This is the team that was set up. In fact, Krishnan also is here. So Krishnan co-chairs this agenda team. Suvimal Ghosh is the convener. And these are the 17 people. And if you look at each of them, they are all young people. They are in 50s or in the oldest of all. So all entire people, and so we wanted to have a young team so that it works. I'm happy many of are here. Vimal is going to attend tomorrow. Sunit is here. then we have Sandeep coming, Tukati, I don't know, and then Sahai is here, Pankaj Kumar here, so many are here, they are part of this kind of team. This is the task that we have to finish this by end of December. This is going to be some halfway, we are halfway, almost 3 rounds of discussions have already taken place. But I think we are going to have 2 more rounds and then finalize this work. Now let me come to what are the major elements of this agenda, the Agenda 2030 and beyond. Now look at the climate modeling side. What challenges we have? We have the issue of process understanding. I think we need to have a much deeper understanding of processes in climate system than what we have. This area is very important. India's specific modeling and regional human component. Now, see, this area is, you know that all of us say that we need India specific model. But connected issue is regional human component. See the kind of land surface processes that we have. I am going to come next and you will see is in India is very different from the kind of model that we have international level, and therefore we need to address these issue about the regional human component very thing. Another area of concern is the high resolution modeling, and in India we do not have the high resolution modeling, many researchers working in this area. Also we have issue over, so modeling will have issue over resolution, this impact and decision tools based on AI ML. Also the huge computing requirement because of the high resolution modeling or the kind of subgrid process and subgrid level resolution modeling, and also the expertise that we have right now is very, very limited in this thing. So what we need is not just modeling, but also we need interdisciplinary knowledge of climate and impact science. This is an area that we need really a lot of work, and then decision support system based on decision tool development based on the AI ML, and through collaborative framework we need to develop, have reduced climate risk, and this is the ultimate goal of the climate, reduce climate risk and improve climate resilience in the country. So the whole lot of issues are there into this climate modeling issue. So in fact, we have been talking about the science and adaptation connect, and there is a feedback. So all that we have in terms of science have direct relevance and relation to the adaptation area, whether it is agriculture, water, disaster, health, coastal, infrastructure, and all these areas are also climate services areas. So basically you are talking about climate science processes leading to application and then finally giving services. So and all that gets feedback into each other. This is a diagram showing how climate science areas are interconnected. Now look at this. We have 4 broad processes: monsoon processes, aerosol climate interaction process, ocean processes, and land processes, all converging at modeling level. And look at the kind of work that we needed. So, you know, on the land processes, we need to have better understanding and representation of carbon uptake and emission, both on the agriculture and forestry, carbon cycle and water cycle interconnection and relation. Also hydrology and cryospheres, working with them. And then in the climate modeling side, we have needed, and as I mentioned, high resolution modeling, and this direct numerical simulation issues, they in fact work at the, for example, for the urban climate modeling and multi-resolution modeling, they will work together at this end. And this is a computer intensive area where we need a lot of computational resources and this thing. And of course, AI and ML working for the decision tools, because when you are going to work for the application, you need this AI ML in a big way. Now, we have been working for GCM, all land, surface, atmosphere, land, ocean, atmosphere. So this is the work that has been done extensively, and most of us use GCM, whether at all levels, and therefore this is the kind of thing that we have been working and have good experience. We now need to work on ESM in a big way. Of course, IITM has, Dr. Krishnan is here, they are already working on Earth system model. I think we need a much more comprehensive and much more India-centric ESM, where the climate and biochemical cycles are truly integrated through various cycles, carbon cycle, nitrogen cycle, and also with entire climate and human activity need to be integrated. This will need a lot of work. In fact, what we are planning, in fact, IITM also have been thinking to set up, but this is the work as part of this climate agenda we will going to do, is set up as India-centric community system model system, where all those who are interested across the country can join and work for the community system model system. This will really make a transformational change, because two ways it will help. One is the capacity building in the ESM, but more importantly that you will have access to global system through a supercomputing grid that we propose to set up. Now, this is the interaction, the aerosol climate interactions are very interesting, and they work at a different level. See, when you are trying to limit climate change, we focus on reducing carbon dioxide, nitrous oxide, methane, and all kinds of things. And this will definitely, reduction of this will benefit climate. But when you are working on air quality, you try to reduce some of these areas like nitrogen, the organic carbon, the sulfates and all. But that is going to put penalty on climate change. And therefore, the compromise between the climate benefit process to the climate penalty process is very important. Therefore, you need to address both the issues. India is going to face air quality issue in a big way. Already all cities are facing those issues of air pollution and all. How do we create a compromise between climate process and the aerosol or the issues of air quality? This is a big issue, and the kind of interaction that you see, the climate system changes along with the radiative cross-forcing and atmospheric changes that is taking place because of air quality. All these are going to work with the entire ecosystem of anthropogenic and natural climate change. And this is an area that we need a big work on this research area. So the aerosol is going to be the biggest, one of the biggest area of research in the country. Again, let me mention here that in the aerosol area, there are 9 ministries working in the government of India. Earth Sciences working, ISRO working, DST working, Agriculture working, Environment working. There is a need to work together. So what we are proposing as part of the consortium, one single mission on aerosol. Put together everybody. Everybody should join and work for one mission. and we cannot have this working in isolation. Now, hydrology and cluster, of course, models again integrating these things, and especially the recent some of the development is in this area. I think we need much more holistic, and this is a very complex water cycle process where human and natural system they interact. We made good progress in the land surface modeling in the 70s to now. We have so much of development and so much of land representation, that process representations had taken place. But what is now required is developing an India-specific modeling where we need to integrate glacier component, water management and crop calendar practices, groundwater. In fact, if you see the groundwater in the presentation in the global scenario, there is in India there is a lateral flow of groundwater which is not there as part of the representation. One big area is soil moisture. Although I think a lot of work has been done, in fact, Vimal did soil moisture estimation. But what we need is validation. So soil moisture need to be validated. We don't have a single network of soil moisture in the country. We need a good network of soil moisture stations, and not just surface moisture, that is satellite estimate surface moisture. I think need the better and deeper thing. And therefore, a lot of land, so this is the gray area for our present Earth system model also. We need to improve Earth system model with these components, and especially India-centric some of these areas. Now, carbon cycle is a very big new concept. It's already, so ocean, land and atmosphere, how the carbon feedback takes place among them. So between the ocean and the atmosphere and between the land and atmosphere, the kind of processes that take place is very, so in fact, this is very important. India has, in fact, after China, has become the biggest, global greening taking place in India. And the two areas of global greening, one is because of the large agricultural intensification that is taking place. So this, so carbon, in fact, CO2 fertilization is the main driver. So whatever instrumental changes that you see is going to, in fact, increase water use efficiency and CO2 fertilization taking place. And therefore, the greening part, in fact, is working to mitigate the emission, and also it actually working to enhancement of carbon intake and evaporative cooling at the agriculture. So China is the first and India is the second country to have this thing. And therefore, many things are there, the key issues, national level vegetation productivity data, carbon uptake potential of forestry and agriculture, carbon and water cycle interconnect, and the Indian vegetation carbon uptake. These are some of the areas of research that are going to come as a part of the carbon cycle. Now, the ultimate goal of carbon of the climate modeling is what? See, you do a lot of good thing, work on the modeling part, everything, product is created, but then where it goes? It goes to the ultimate user, say farmers. And therefore, and further farmers, what they need? They need district level advisory. Now, you can say that agricultural advisory is already there. And he is doing. I think that we need to supplement with a lot of other information. These are not given right now to the farmers. And when we talk about the farmers, we are talking one end only as the user. But connected with that is many ends. We need climate, all these people to work together. Climate modeler, data scientists, government official, NGOs, farmers, social scientists, agronomists and hydrologists to work together. Although there are committees to work, I think we need much more inclusive and intimate interaction than what we have. And therefore, the solution approach that we currently have need to be upscale, and that we need a lot of work on this front. So the user end is still a gray area for us, although we work so much for that. As I said, AI ML to climate science is going to be future of our research. So theory guided data science models work at the intersection of physical model, machine intelligence, and high performing computing. This goes as possibility framework, and decision models are developed to create decisions by the policymakers. And this is the entire system that we need to develop. So scientists have worked up to this level. We need to work beyond that. So this is the area of research that we need to work. Now, this is a changing definition of climate risk. We had, as I said earlier, only hazard connected with the risk. We used to think that risk is because of the hazard. But then the AR4 said that no, it is vulnerability, the hazard and the exposure, all three are important, and the risk is at the intersection of these three. Now in the AR6, we added the response system. So you can think of, so all that, this fourth dimension of risk is added to the in the AR6 system, where I'll give you examples. Say, IND says the cyclone forecasting has improved. No doubt, it has improved. What kind of response it has generated? It actually impacted one thing, very big way, that your higher accuracy and better warning has led to a reduction in number of deaths. So the response of the community is that a cyclone, impending cyclone, not to worry, just get prepared, because you have achieved the level where accuracy of the forecast has increased, so the number of deaths are going to be very less. That is a system that we need to develop, create impact forecasting, and develop response based on that. This is my last slide. So I talked about the climate. Now this is the last slide showing the vision for the weather modeling, weather forecasting. Now you see, this is the vision that National Weather Service USA has prepared for 2030. And these are all statements. We don't know how much it will work. They will work on it. Satellite observation will tactically replace all instrumental observation, which means there will be no need for any instrumental observation. These are all statements. I am not agreeing with this, because as a meteorologist, we should contest. So I am not saying this is vision for India. This is the National Weather Service. And they are saying meteorological dependence on synoptic observation will become obsolete. So practically you don't need any observation, you don't need any RSW observation, and satellite will give you everything. And the assimilation, they are saying it will become near perfect, so that your analysis will be like your observation. So analysis observation will become similar. And global model to run for 30 days, less than 1 kilometer horizontal and 100 meter vertical. And observational error in the Inaugural model technically eliminated virtually completely. These are all, I think I would consider it is mostly daydreams, because this is impossible. Meteorology is not a linear science where you can do this. Anyway, so this is a kind of vision that I am not saying that I agree on this. This is mostly very philosophical and very much ambitious. I don't think we can agree. So I think I would end here and say concluding remarks that climate change is impacting extreme events in a big way. The impact on India is going to be enormous. This is one thing that we need a long-term plan to make itself ready to face the consequences. They need to build human and institutional capacities in climate research in the country, and therefore the climate research agenda is needed. The intensity, there is going to be increase in the frequency, intensity, and duration of extreme events, and this is going to pose a lot of challenges on weather forecasting. And therefore, we need to upscale weather forecasting and multi-hazard warning system. Monsoon is going to be highly variable and unpredictable, and therefore this is going to be a challenge for the sea. Now, so therefore there is a need for all the research funding agencies to work together to support the strategic area of weather and climate research in a mission mode. So this is the purpose of this consortium, where we will try to set up some research fund so that we are able to support the high-end research in the climate area in the country, not just for the intramural purpose but also extramural. These are huge expectations from the community, and especially the young people are looking towards the funding agency. We are not going to unfold the strategy that we are working on, but I can promise that we are going to work on a strategy where we will try to serve the larger purpose and going with a larger vision of upscaling the climate research in the country to help addressing the issues that are going to come up as part of the climate projection in the country. I think I would end here. I must acknowledge the support from Subimal Ghosh. He has in fact given most of the slides that I presented at the end was provided by Subimal. So none of them are my own, so I am only integrator and presenter. And although entire climate research agenda drafting team, some of them are here, so they have all we, in fact, as I said, by end of December, we are going to finalize the agenda. First cut of the agenda is going to be finalized. It will be circulated to the community for wider consultation and suggestion. And by March, we are going to present this agenda to a national conclave and finalize, and then all funding agencies will sit together and finalize. We want to follow a US system where when a national agenda is created, and create the element of funding and identify people who will lead the different elements of the funding. This is the idea that which we are going forward. Thank you so much for your question. Yes, yes, please.
I'd like to know the support to the DST for state-funded universities and also the continued support for research, number one. Number two is DST's efforts in introducing the climate sciences at the undergrad level. I would like to know.
So, let me tell you, SERB has recently launched a state-centric funding system, only state university. State university research support is given by SERB for the first time in the country. Because state university, cannot compete with IITs and IISER and nothing. And we know very well. So this is a specific. So how many applications have been received? 6,000. 6,000 proposals have been received. We are in fact targeting to fund only 300, but now in fact in the SERB we decided to increase it to 500. So 500 people will be funded this year from only state universities. And the other question is about
the introduction of climate sciences at the undergrad level.
Yeah, that is not our job. See, the DST should know where is the limit. So that is the job of Ministry of Education. You talk to them.
Raglesh, very nice lecture, but one thing, no, you said that in India, as far as India is concerned, climate change is more drought. It's not more drought, and also you told in another slide that it will also actually increase the number of floods. Does it not contradict?
No, it's not contradictory. First of all, you know, our confidence on increasing drought is not much. So, in fact, our Krishnan will tell you more detail. But it is already happening. You see, one part of the country has drought, other part has the flood, put together normal monsoon. This is what is happening. So, variability, both in time and space, is taking place. More frequent heavy rainfall, short-lived, heavy rainfall at the level of, say, city. So, city rainfalls are increasing. And you know, there is a study done recently, maybe many people knowing, I think it was done by Cristobal, that, you know, there is a close relation between the population density and the rainfall intensity. So I think we are now moving towards a side where the rainfall and drought, I mean heavy rainfall and drought, both are going to happen.
A very short question, sir. You can.
I thought your plan of future is very well thought of. I remember an article almost written about 50 years back on Professor Adrian Gill. He said a three-pronged approach for future research, what he called KUM. K is knowledge, U is understanding, M is model. That's exactly what the middle picture you showed. First observation, then understanding. You stretch on understanding, which I heard many talks earlier, that is totally missing. But unlike these talks, you stress on understanding, that I think is fundamental, and finally modeling. And now, there is one thing I thought probably you can think a little bit, unlike middle and highlight codes, where the dynamics is mainly controlled by the barophilic system, which are from 1 to 7 wave number. That is, what happens in west will happen in east after some time. And in the case of tropics, it is very, very different. What happens in Africa is different from what happens.
Sir, can you please make it short? We are having shortage of time. Please make it short, sir.
Okay. So what happens in India in one season is different from other seasons. So you have to give some stress about the parameterization of convection. I think that is very important.
I think I already mentioned, I think it was there in modeling, parameterization is very key, and that's what the process is. So I do not agree that India is completely gyrotropic. We have gyroclinicity. During monsoon, we have so much of gyroclinic system also. Yeah.
Just one very short question from the young faculties or scientist or researcher from the back. We are running shortage of time. Yes, please. Go ahead. Very crisp and short question.
We are most focused on the modeling in comparison to the observational section. So whether when we are planning, we are focused to give the budget equally to modeling section as well as the observational section, so that the relationship could be found and then feed to the model.
So, you know, you are right. You know, so I'll tell you very frankly, when Dr. Ravichandran and myself, we said, you know, all this was planned on the breakfast table, by the way. So let's separate out the observation part, because that is entirely in the domain of Ministry of Earth Sciences. This plan is for research. And we knew that there are issues of observation, very serious issues are there. So I did include some issue like soil moisture, which is very critical now. But I think
I don't deny there's a big issue on observation, and we need to take that also in thing. And therefore, if a successful research program need to be executed, that cannot happen without a very comprehensive observational program. I agree with you.
Okay, that's quick, very quick.
Yeah, just as part of COP27 recommendation, we have said that we need a loss and damage modeling also. So how DST is going to plan?
So
this is not a part of meteorology traditional.
So you know the outcome of loss and damage in the recent COP. So basically, India wanted to put the loss and damage as a center stage. See, we lose 2% of the GDP every year due to extreme events, 2%. And where is the compensation for us? Apart from the adaptation is one part. 2% of GDP, who is going to pay? So this is India is in fact the kind of warning system and paraphernalia that we have set up as part of the Ministry of Science and all is serving well to the country. But we need to have a proper this kind of thing addressed to a national policy. So I agree we still are not very clear on loss and damage.
Sir, thank you very much for giving an exhaustive views, and we have all seen in him that he has shown much concern to the climate research program with DST, with MOES. He has shown what are the Vision 2030. There is a tremendous scope and opportunity for the young scientists, researchers and faculties to address the issues, and what Professor just now mentioned about KUM, knowledge, understanding and modeling. These are all different aspects. If we concentrate in different areas, that will definitely understand several issues, and then we'll be able to make some sort of modeling. Sir, once again,
thank you. Thank you so much.
It is always very nice to hear from you, and climate research is always into the forefront because we are seeing its impact, we are seeing its evidences, and it is making a lot of implications to the society, health security, water security, energy security, as well as many aspects of our life. So there is a tremendous scope and opportunity to take up the climate research, involve in different areas, and contribute for the growth of the science so that we'll make a socio-economic cultural growth of our country. Thank you very much.
Thank you. Just wanted to say at the end, see, I have always been concerned about the young people, and especially the students. So I wanted to give a good news that, SERV has, a scheme called NPDF, National Postdoctoral Fellowship. And annually we give 300 postdoctoral fellowship. Okay, so after I took over as secretary, we thought that you must increase this number. So from this year onward, we will have 1,000 a year.
So I know that as this is so important topic, there will be endless questions. And all of you can interact with Dr. Gupta during the lunch time. Thank you very much. So we conclude the session here.
Participants who still haven't shared their presentation said they can share it in the email ID or you can share it in the PPT booth outside as well.
Tell the sessions and all.
Yes, we are saying.
So we are going. So just for your attention, please. So we will be now splitting into the different sessions, and the dynamics and climate change will be in this auditorium. So the speakers and the people who are interested, participants interested in this topic, dynamics and climate change, are staying here. Ocean variability and extremes, they are going to the hall number 1 upstairs, seminar hall 1, and cryosphere and glaciology are going into seminar hall 2, that also is on the upstairs. So kindly make it convenient. We will start the session in next 10 minutes. in respective halls. Thank you.
in the besides plenaries. This is the first technical session that way. And in this we have the session is on dynamics and climate change. And the keynote address will be given by Professor Ravi Shankar Nanjundaya, my old friend for last many years. He has been at the frontier of the modeling. And you know, for some of the youngsters in the back, he has been the director of the Indian Institute of Tropical Meteorology, a very, very premier research organization in the climate change research. And he was director there. And before that, he was the Indian Institute of Science, Bangalore for many years. And after IITM director, again, he is at the Indian Institute of Science, Bangalore. So he has been doing, so we have been interacting a lot, that he does a lot of numerical modeling. And one interesting thing I have found whenever interacting, he is a very quiet person. You will always see very quiet and calm person, but the knowledge is very, very deep. So we expect a very good lecture by Dr. Nanjundaya. Sir, 20 minutes, please go ahead. Yeah. Thank you. Thank you very much.
Tell me, because like professors will talk a lot. So
my job is only there to tell the time.
Professor R. Krishnan, if you are around.
He is not here.
Well, we could not see him there actually, that's why. Sir, please, I'm so sorry.
I would rather prefer to keep this so that I can walk around. This will interfere, so I'll just put it to. Hello, hello. Can you hear? Yeah, hand mic is fine for me. I think it's working. Good. Fine. So you'll remove this, or? Okay. Okay. I'll start. So, good afternoon, and first of all, I would like to thank Dr. Joshi for his very flattering introduction. Well, it's not working? Okay. So, I'm going to talk about AI and ML. And as was repeatedly stressed by Dr. Akhilesh and others, this is one area where we need to really work on. And this is where I think the youngsters, the younger generation has to kind of take the baton from us and go further. We can only do that much with AI ML. We can hardly understand it, to tell you the truth. The youngsters have to take it further. Okay? So I'll tell you something about what we can do with AI ML and what we have tried to do with AI ML. Oh yeah, sorry. Okay, so why do we need AI ML in earth sciences, especially in climate and oceanic sciences? The current thing that's happening is that you have a huge amount of data coming, and you have a huge number of observations and data coming from all sources. It could be from satellites, it could be from subsurface on conventional stations. So all this data is going to come. And you also have bigger computers. So the idea is that we kind of look at it and see what we can do more than what's already been done with all this data, and how we can kind of improve the other leg of studies, that is modeling, for both prediction as well as, let's say, understanding of the subject. So these are the areas where we can use AI and ML in weather and climate. Of course, one of them is weather and climate at various scales. And the second one is on, these are areas I'm just kind of mentioning. It's downscaling, that is, you have data at fine scales, and at coarser scales, and then for various things you could use this AI/ML technique very effectively to a smaller scale, so that you can kind of get those smaller scale picture, which could be like, data from climate change. Our climate change models typically run at about 100 kilometers today. It could be running at 50 in the future, but then it certainly won't be going into 1 kilometer in the near future, as far as I can see. But we do need data at much finer scales. For example, if you need to take a decision in, let's say, for a state or even a subdivision of a state, then you need to have data for that. And for that, your climate models by themselves will not give you this data. That's where downscaling it comes into picture. Basically, you kind of take data to coarser scale and try to make it into a finer scale. We'll come to that in a moment. Then one area which is data assimilation, that is, you have input data coming from various sources, and you would like to create a good initial condition, also an analysis to kind of do various studies. And that is a new technique which is now kind of just being born, I would say. It's called deep learning, where you take conventional data, such as, and also techniques like Kalman filtering, and combine it with deep learning, that is both of them together, and we call it as data learning. Okay. Another area where we can use it is the bias correction of weather forecasts. Unfortunately, there are biases in most models, and we would like to improve our forecasts. Whatever forecast comes from the model, we can still improve, because we have a large amount of data now coming from both conventional modeling and previous forecasts and observations. So we would like to combine the two so that we can reduce the bias in our weather forecasts. Prediction of extremes. Dr. Akhilesh mentioned that this is going to be more and more important, especially when you're in a changing climate scenario. And you'll likely to have more heat waves, more cold waves, higher rainfall events. All of that are likely to happen in the future. Or actually, I would say that climate change is already upon us, and we are seeing more extreme events. And we need to predict on a fairly finer scale. If you'd like your prediction, let's say, for one part of Bhopal, and see how rainfall is happening, it could be very different, let's say, about 20 kilometers away, which any conventional model may not be able to capture. That's where I think we can use AI and ML to kind of predict extremes, maybe with different lags or leads. The other area where we can look at is called as hybridization. That is, we already have numerical models. We can combine it with machine learning models. One of the areas could be where you have these clouds, which occur, let's say, at kilometer or sub-kilometer scales. Your models are running at about 10 kilometers. But the impact of cloud is very important, and you cannot resolve it. So to kind of take that, we usually use parameterizations. Now, parameterizations usually happen because you take one observational data set from somewhere. For example, most of the current cumulus parameterizations are based on some data coming from Atlantic. And that's about 20 to 30 years back. And on that, cumulus parameterizations have been set up. Newer ones, of course, are happening. But now we have data from satellites, a large number of large data which have come from satellites. And we would like to combine this information and create a new parameterization which could be applicable to different parts of the globe. And that would be one area where you can kind of use machine learning with this large data and kind of marry it off with numerical models. And if you're going to very fine scales, like that of a solar or a wind farm, you can certainly use AI/ML. In some sense, it would be, could say that it's downscaling, but it will be much more than that when you're going to fine scale, such as that a solar farm. That's called as feature engineering. And you can also use it through a data set. That is, you have different data sets on one side of the machine learning. That is, you have these, most of you would have already heard about NCEP-NCAR reanalysis and the ERA reanalysis. That becomes a huge data set for you, and you can push it into a machine learning algorithm where you can use it. And on the other hand, which is what we would be interested in, is the problems that we can solve. So what are these problems? We have this problem of air pollution, which Dr. Akhilesh also mentioned. Then cyclones, heat waves, lightning forecasts, climate prediction, decadal prediction, seasonal scale forecasts, etc., etc., etc. Okay, and these are the tools which I think the younger set is already familiar with, things like PyTorch, etc., etc. Okay, so that's one more link to connect to machine learning. And then you have education, where you can bring in deep reinforcement, learning techniques, etc. So I'm not going to the details of it, but this is like a mind map which has been used to not just for, actually we built it up not just for atmospheric science, but also for entire earth sciences we had done it. There's a very nice review. I recommend that you can read it. It's freely downloadable. It's in current science, so freely downloadable. Okay. So actually I also would like to tell you that there's a virtual AI/ML center which has been set up at IITM, especially related to earth and climate sciences, or earth sciences in general, with particular reference for climate and weather studies. So now let's move into the first area, that is downscaling. So if you look at downscaling, it's a procedure of using data from climate models at coarser resolution to provide predictions at finer temporal and spatial scales. That is, if you have a monthly data or a daily data, you'd like to take a 3-hourly data, and the model might be giving you at 50 kilometers or so. You would like to have it at 1 kilometer or sub-kilometer scales. You can use this downscaling technique. That's where I think the deep learning techniques would come into picture. And there are a variety of those techniques which are there, such as ANN, the artificial neural network, long-short memory, LSTM, multilinear regression, support regression, etc., etc. And further, we can use this downscale data for hydrological models to estimate stream flows. So this is a picture where you kind of get a coarser data and then kind of try to get the finer picture using downscaling techniques. So this is one case study of a downscaling technique. We took data from IMD, more like a case study, I will say, where the data is currently available on daily scale at 25 kilometers. And we try to kind of downscale it to 12.5 and 6.25. So the picture on the left is what the model is, the original data set which IMD has created. And this is at 12.5 kilometers, and this is at 6.25. And some of the smaller scale features, depending on additional information that you give, you can always catch it at the downscale. So what I would like to mention that we did not have data at 12.5 kilometers or 6.25, and hence we checked the model by converting to 100 kilometers of IMD just to see that whether the technique works correctly or not. And these are the other details which I will not go into. So we some time back, I guess about 15 years back, we tried to do some downscaling for climate studies. And this was way back in 2009, where we used one of what was then considered to be the technique, support vector machine. And this was for a small river basin in northern Karnataka called Malaprabha. And we used various input predictors like long wave fluxes, short wave fluxes, etc. And the sensible heat and the latent heat fluxes. And downscaled Tmin and Tmax, that is maximum temperature and minimum temperature, using SVM. So these are some of the We took the data from the IPCC at that time, I guess AR4, and see what happened. Because the data would come at a very coastal level, and you would like to see what would happen to the particular basin. And for various scenarios, you can see that the temperatures are increasing. Another area where we can use data assimilation is where you get raw data from different sources, including satellites, etc., and model simulation. So you would like to combine the two of them. And we need to do assimilation to produce reliable and evenly distributed climatic variables at grid resolutions. Because you would like to have a nice gridded data which you can analyze rather than have a kind of a station kind of a thing. 5 more minutes. Okay, then I have to really rush through, but this would be one area where data learning overcomes limitations in applying data assimilation and ML to a real world problem. Bias correction, we know, as we said, we have problems in the input, the predictions that we get. We would like to make them better. So we use ML-based techniques like neural network or deep belief network to kind of create a bias correction for the model. Hybridization, which I mentioned, that is, we have physics-based models, the current numerical models, and we can use machine learning models, that is, data towards knowledge and mathematical model together in a synergistic relationship. One of them could be, as I mentioned, was the cumulus parameterization problem. Similarly, anywhere you are kind of putting data in an empirical form way in any numerical model, you can use this hybridization between physics-based model and machine learning. That would be a nice way to kind of bring the two together. I guess one area where we, or rather my postdoc worked on, was solar forecasting using a technique called dilated convolutional neural network. I'll skip in the interest of time. And this was some of the details that we have done. And this is some data. She at that time was working in US, and she did that solar forecasting for Boulder for 2 centers, that is one at Boulder, Colorado, and the other one at Fort Peck. So what she found was that the RMSEs were lower when you use convolutional neural network as compared to simple persistence models. So it certainly is a fairly promising tool, I would say. This was just more of a proof of concept, but it certainly was useful. And this is how the predicted one, it didn't do greatly, but it's certainly better than what persistence would have given. And this is the comparison between persistence and our model. I'll quickly talk about prediction of monsoons at various scales. One of them we used is what's called as a stacked encoder approach to monsoon prediction. So this is basically an automated feature learning and identifying new monsoon predictors. Then features at different levels of the abstraction are learned, and the deeper the layer that you make, the more complex are the features. So these are some of the predictors that we took, like sea level pressure, temperatures at 2 meters, etc., and kind of reduce the resolution using stacked encoder, and then fed it into a model. And it seems to be doing pretty well. So the combined predictors gives you about 3.7%, that is of sea level pressure and wind at, I guess, at 850 hectopascal, and sea level pressure by itself gives you a 4% improvement. And this is comparison with existing models, and it certainly looks like this model, the deep learning based model, is doing better than the other statistical techniques. We also did for early part of the monsoon and the late part of the monsoon. I'll skip all that, but it seems that it's doing pretty well as compared to conventional techniques. That forecast for the early part of the monsoon is at 6.1% as compared with a standard deviation about 12%. And the error is in the later part, that is, let's say in August and September, is much lower as compared to the earlier part. And this is some comparison. And for the whole homogeneous regions, we have, which IMD has already mentioned, the different regions. We built a stacked encoder-based model for this. And these are the results. And what I would like to stress again is that it's doing a pretty useful job as compared to conventional statistical models and comparable to what the numerical models, which need a lot more computing. I'm not saying conventional numerical models are good. I've been working it all the life, but this seems to be a promising technique we can take. And these are some of the details. This is about active and break spells. Quite a bit of work has also been done by others, including Dr. Sahai and Dr. Chattopadhyay, on using self-organizing maps. We used LSTM techniques, and we got reasonably good results. Well, at longer lags, there is a problem. The error kind of drops significantly as you go longer in time. This is one technique which is also an emerging technique, which is called as this is deep learning weather prediction with DLWPS, which he recently published. One of my young colleagues, Dr. Manmeet, he has published this this paper, and uses the concept of a digital twin. So other details I'll just skip and say that we have the MDL WPS-CS seems to be doing better. This is comparable. This is GFS with ERA5 analysis, and this is our technique. So we can say that it's doing as well as GFS. This is just a first cut of it, and I'm sure we can do much better. And certainly doing better than linear regression. This is the correlation coefficients. This is for our technique.
Maybe the last slide you can put.
Sure.
Summarizing.
There's nothing much in the last slide.
Okay.
This is it. And we have done also for ENSO.
Yes.
So in summary, what I would like to say is that there is tremendous scope to use AI and ML, perhaps as a hybrid model, perhaps as a standalone model. So I think that's where the youngsters can take over.
Thank you, Ravi. Thank you very much. So one or two questions. So can we go first to the back side, if any student? No? Yes. Ramakrishnan.
Thank you, sir. According to Ed Lawrence and later by Yoshio Kurihara, if you take two initial states, similar states, one will develop into a cyclone and one will not. Do you think AI will be able to explain this?
It's always difficult to explain with AI because, and I mean, understanding is you may not be able to get much with AI, but you can certainly get better predictions. Quite often we don't understand why AI is doing well, but it certainly does better. And of course, there is understandable AI now coming into picture. Perhaps we could be able to do it, and you might be able to get more insight using AI/ML as compared to a conventional. It depends partly on the training, and also, there are specialized techniques, which is called as understandable AI, which also you can use. But we have not used it, so I cannot comment on that. But I'm sure we can do it. As time develops, it will become better and better. Yeah.
So one is a small comment and then question. For the comment, I would like to know your views. Compared to the type of problem-solving success that's seen in other sectors, meteorology, climate science, AI/ML is yet to demonstrate the kind of problem-solving success seen in gaming and other industries, traffic management. So that's my comment. I would like to know your views. Secondly, specifically, till now, like I've not come in the review or in any of the literature, like AI/ML techniques able to predict unseen type of events, like one of a kind, like Mumbai heavy rain or Chennai flooding kind of an event. So unseen data predicting them still is not yet demonstrated. So do we have any, are we missing something like the insiders of meteorology?
Okay, thank you. The first question for which my answer is, you're looking at a much more complicated system. I mean, just as a lighter comment, it is said that Einstein was asked, and he said, if he meets God, he'll ask him about turbulence and weather and how it is kind of determined. So I think that answers your question. As far as why we are not able to do unseen events, these techniques are still developing and not being used in an operational scale. I'm sure if we do the same thing with some hindcast data, we should be able to do it. For example, we are able to do quite a few of the previous droughts without looking at those data. That is, you are not using that data, but still you are able to look at droughts and break spells and active spells. Certainly we are doing it without actually looking at the data which was being fed in before. Okay. So I think it is a very rapidly developing field. So It happens
you.
every day. Every day I see a new technique and I don't
Yes,
understand
it will.
completely.
Thank you.
Okay.
If it is a quick one now because we are.
Okay, Partha.
Who actually instigated me? I was not wanted to take time. The problem is, see, it's a data-driven thing, right? Now, in Kerala event, it's a 1 in 100-year event. Mumbai is a 1 in 100-year event. You are not driving the system with 1 in 100-year event. So naturally.
Okay, Partha. No, I understood. See, there are techniques which are.
My question is, so if the data is not driven by extremes, how do you improve the variability? That's $1 billion.
Well, there are techniques which are used to capture extreme events. There are techniques in AI and ML which you can, I mean, there are separate techniques for that. If you use them, and again I have to look at data. I mean, if I don't see the data of Mars and try to use the same model, obviously it will collapse and fall under space. Okay.
Last one and a quick one.
Thank you, Dr. Joshi. I am Vinay Sehgal from Indian Agriculture Research Institute, and our stakeholders are farmer. And one of the great job which has been done in climate science is providing agro-advisory services. But still, it has not yet come to the level of farm scale or a scale less than 1 kilometer resolution. So do you see much use of AI ML in downscaling to 1 kilometer or less than 1 kilometer using some other satellite-based parameters which are available at high resolution?
Yeah, both conventional and satellite-based data, you should be able to do it. Of course, you'll have to develop the model. I mean, it could be very specific. Let's say for a district, it might be different, or even at a sub-district. But then these are fast and easy to run. So we should be able to do that. But I myself have not done it, so I cannot say. But yeah, for at a stream flow level, we have done it at a very small river.
One from the younger, yeah, please.
So when we are using AI for monsoon prediction and everything. So actually monsoon is a large scale phenomenon which is dependent on a lot of economic variables. But when we are using AI, there's a number of variables only we can predict compared to other variables. But after I'm confused that if we are not using all the variables, how the scientific community will take it, it is not actively all equations and everything. We are using very less number of explanatory variables only. How the scientific community will take it,
Okay, I'll give an analogy. When numerical prediction started, the conventional meteorologists were not willing to accept. Okay, but then slowly they saw how good the method was, and now it has been taken. They have kind of accepted it, and it's become the norm now. So, I mean, over a period of time, I'm sure they will accept it. Okay.
Okay, no more because we are already quite late. You can please discuss later. So we end this invited talk. My only comment at the end will be artificial intelligence is anyway artificial. So there will be some limitation with the intelligence. So there is difference between intelligence and artificial. There is bound to be somewhere some problem with the AI.
Human intelligence can never.
Yes.
I mean, I'll say it will always beat the artificial intelligence.
Thank you very much. Thank you, Ravi. You can speak to him later. Sorry. We move to the next one. We have two invited speakers. First is Professor Suneet Dwivedi from University of Allahabad. And he will be speaking on multi-decadal variability in the teleconnection between Eurasian snow cover and Indian summer monsoon rainfall. I thought he is an ocean modeler, but here I find he is talking on something, but that is going to be interesting. Please go ahead, 15 minutes. Thank you very much.
Yeah, today, good afternoon everyone. I am Suneet Dwivedi from University of Allahabad, and today I am going to talk about relatively less studied this teleconnection between the Indian summer monsoon rainfall and the Eurasian snow cover on a multi-decadal time scale. I will discuss even though the limit of predictability of the monsoon has reached to nearly 70%, but using the dominant or using the well-known predictable drivers of the monsoon, for example ENSO, for example PDO, if we combine them, then we can predict the monsoon on a seasonal or from interannual to longer time scales, up to 50% at best of the times and 10 to 20% at worst of the times. So there should be some more predictable drivers which are into action, and we are not emphasizing more on them actually on a longer time scale. So it is, and there was no research actually. The past researches have been done to see the teleconnection between the this Eurasian snow cover fraction and the Indian monsoon rainfall, but there was no research which was available, which has analyzed or seen the variability on a multi-decadal time scale. So here our emphasis was more to see the multi-decadal time scale and how this Indian monsoon actually varies on a multi-decadal time scale with service variability of the snow cover fraction, and what are the major factors which are regulating this multi-decadal variability, if not ENSO, if not PDO, if not like IOD or this Atlantic multi-decadal oscillation, then what is driving it? So for that purpose, we have done some causal teleconnections also, which is a new technique. We have seen the cause-effect relationship of the ENSO with the of the NAO with the snow cover fraction and with the Indian monsoon rainfall, and we have come up with a mechanism how this snow cover fraction, it actually regulates the North Atlantic oscillation and then to the Indian summer monsoon rainfall through the modulation of tropospheric temperature gradient, and this is what I am going to actually show you in the following slides. But we can predict using the known drivers of the monsoon rainfall, we can predict monsoon at best times to only 50%.
Maybe you can go to mic.
Actually,
no, you can go there. From there, if you can speak.
So you can speak from here as well. Also not working, no? Is it working? Yeah, because it is very inconvenient to take it hand and just speak. Yeah. Yeah, it is better now. Yeah, so ENSO monsoon teleconnection can explain 40% of the variability. So this is especially important for those teleconnections which are known from decades, actually centuries, but they have not been actually looked into more detail, and therefore we have actually seen, especially the land surface forcings or the teleconnection of the Indian summer monsoon rainfall with the sea level pressure from the extratropics or the sea surface temperature from the extratropics, and the teleconnection of the Indian summer monsoon rainfall with the snow cover fraction from the Eurasian region. So researches have been done to see the Himalayan Tibetan plateau snow cover fraction, its teleconnection with the monsoon, the teleconnection of the snow cover fraction with the monsoon, but not over a longer duration of time. So it was desirable to estimate how much variance of ISMR internal variability could be attributed, if at all, to the Eurasian snow cover variability. So the question that we have asked, are these changes specific to this period? Recently we have seen that there is a lot of epochal variation from a negative actually teleconnection between the Indian summer monsoon rainfall and snow cover fraction to a very high positive teleconnection. From 1967 to 2015, we have seen a dramatic drift between the teleconnection of the Indian summer monsoon rainfall and snow cover fraction. So whether these patterns are limited to this particular period, or it was a slowly varying process which is happening from the last century. So this is the question that we have asked, and whether there is a trend in the teleconnection between the Eurasian snow cover fraction and the monsoon rainfall. So these are the two major questions that we have asked, and these are the data used. I will be telling you more about these data sets as we go ahead in the slides. And this is the causal inference method. This is the new method, and I have used the PCMCI method along with the along with the Gaussian process regression and distance correlation. So this is the new method for looking at the causality analysis or causal teleconnections. Suppose we find teleconnection between those two phenomena. So what is the cause and effect, which process is driving the process, how they are interconnected, and whether this is like this teleconnection is regulated by various processes. So for that purpose we have also employed the causal inference method, PCMCI, and I started by doing the famous EOF analysis, and we actually extracted the dominant mode of periodicity, and this is the ISMR PC1, ISMR PC2. These are two dominant modes. So this is well-known graph. So this ISMR PC1 I have taken as the ISMR index because it relates very well with the IITM homogeneous rainfall index, and the other one is the dipolar ISMR2 index. And this is the first result that I wanted to show you. This is the spatial teleconnection between the PC, like the ISMR1, and the March-April-May snow cover fraction. So here you see that these are the three cartoons. In the first one, this is from 1901 to 2015. This one is from 1961 to 1990, and this is 1991 to 2015. So I have taken these two periods because a dramatic shift has been observed in the interrelationship between the snow cover fraction and Indian monsoon rainfall between these two periods. So the teleconnection changing from high negative to high positive between these two periods. So that is why I have taken, and there was no index actually which was actually a universal kind of index to define the snow cover fraction. People have seen the effect of snow cover fraction from the eastern and western side of the Eurasian snow cover fraction, and the results were very different. Similarly, if you take the central Eurasian region, then the results were actually different. So here, if you see this from this correlation analysis, we see that actually there is indeed a great shift in the teleconnection between the snow cover fraction and Indian summer monsoon rainfall from being very highly negative in 1961 to 1990 over the central Eurasian period. It has become highly positive over the eastern Eurasian period. And similarly, there is a monopolar kind of actually structure existing. When we relate the PC2 with the snow cover fraction, this pattern shifts from central Eurasian region to eastern Eurasian region. So based on these two, based on this particular analysis, we have defined actually two new snow cover fraction indices, namely the SCF1 and SCF2. SCF1 is taken as the difference from difference of snow cover fraction over this particular region, black box, minus the magenta box over this particular region, and that is how we created the snow cover fraction index 1. And similarly, if we take the difference between these two, then the snow cover fraction index 2 is defined, and the periodicity of these two actually indices, it matches very well with the periodicity of Indian summer monsoon rainfall, the PC1 and PC2, as well as the snow cover fraction. So these two indices actually they have the same periodicity. So then what we have done, we have actually carried out a moving correlation analysis between the snow cover fraction and the ISMR index, and this is how the curve looks like. You see that except over this particular region with the central period of 1958 in the 15-year moving correlation, and this analysis has been carried out from 1901 to 2015, taking the data from 20th century analysis. So only during this particular period you find a negative correlation. Otherwise, the correlation is positive, and it is becoming dominantly positive actually in the recent decades under the influence of global warming. So it proves that ISMR, actually the snow cover fraction is becoming a very reliable, it is becoming a good predictor of the new summer monsoon rainfall in the context of climate change. Also the snow cover fraction and ISMR PC2 moving correlation analysis, and here you see a little bit of decrease in the correlation, which is actually observed in the observations also. So these from the SCO, and we have also actually carried out the same analysis using the observed data from 1967. So the data from reanalysis, it matches well with the observations. So we can actually say that the snow cover fraction from the reanalysis is reasonable, and the close correspondence between the observed and reanalysis data is seen. And the periodicity is like nearly 30 to 45 years in the correlation, moving correlation between snow cover fraction 1 and ISMR PC1, and this is nearly 60 to 70 years or 50 to 60 years for the snow cover fraction 2 and PC2. And we also see that there is a trend also actually, there is a positive trend is also there in the long-term correlation. So not only the trend is there, but multi-decadal variability in the correlation is also seen. So what we have computed the standard deviation of this multi-decadal variability and the trend. So in this particular case, they were of the same order actually. The multi-decadal variability and the trend are of the same order, whereas in this particular case, multi-decadal variability is much stronger as compared to the trend. So in order to actually see whether these particular actually indices are how these indices are relating with the total IITM mean monsoon rainfall, the internal monsoon rainfall. So we found that the correlation between ISMR PC1 and IITM rainfall, the IITM rainfall data is nearly 0.86. So we have taken the nearly 0.86. So this particular index is taken ISMR PC1 and IITM JJ's rainfall. So we have also carried out the same analysis using the IITM data, and the results match very well with they match very well with each other. You find that the ISMR PC1 and SCF1 index moving correlation matches very well with the IITM JJ's rainfall and SCF1 index correlation. So that is why then we can say that the Eurasian snow cover fraction is a useful predictor of the ISMR over these time periods. And we have also checked the influence of, actually if we go to the previous slide, we have also checked the influence of ENSO, IOD, PDO and the AMO phenomenon by actually linearly removing those signals from this particular time series. And we found that the influence of these particular like oceanic climatic modes is not there actually on the relationship between the snow cover fraction, on the teleconnection between the snow cover fraction and the Indian monsoon rainfall on these time scales or over a particular century. So then we started to look at the factors, diagnose the factors which are responsible for this particular teleconnection. So the first thing that we did was to look at the same correlation with the tropospheric temperature gradient, which is responsible for onset and withdrawal of the monsoon, JGS monsoon. So we find that, so this is the curve of this blue curve denotes the correlation, the moving correlation between the snow cover fraction and tropospheric temperature gradient, whereas the black one is the earlier curve. So we find that the similarity and the coherence in multi-decadal variability suggests the mechanism of SCF influencing the ISMR. So in order to, so then we also actually further to see the robustness in this relationship, we have regressed SCF on the tropospheric temperature anomalies for 3 different periods, 2001 to 2015, depending on this particular graph corresponding to positive and negative correlations. And we found that this particular, when the tropospheric temperature gradient is positive, we see very high rainfall in these 2 periods, whereas when the tropospheric temperature gradient is negative, we see the lesser rainfall over this particular period. So this particular graph shows the robustness of SCF index. And to further diagnose why this is happening, this particular phenomena, if none of the climatic modes coming from the ocean are responsible for this particular phenomena, then something from the atmosphere must be responsible for this. So we look at the relationship with the North Atlantic Oscillation Index, and we found that, and this is the actually SCF1 and ISMR, these are shown by black lines, whereas SCF1 for 2 different regions, for March, April, May, and for the February, March, April season, you see they are highly coherent with each other, and they go one in one, and if you see the correlation of the ISMR and NAO also with the connectivity, you find that whenever they are, both of them are decreasing together, then we see very high correlation between the SCF and the ISMR. So snow cover fraction becomes really important when the steric connection between the ISMR NAO and snow cover NAO is increasing. So in order to, so in order to further look at why this is happening, we have done the causal teleconnection analysis also. So this particular graph is very important. Here you see which mechanism is driving the other mechanism. Here you find that the TTG and ISMR, they are confounded. There is no simultaneous teleconnection between the TTG and ISMR. This is also true actually, because after the monsoon sets in, ISMR actually influences the TTG see these are shown the lags in months. ISMR influences the tropospheric temperature gradient at a lag of 2 months. So snow cover fraction is also not actually simultaneously connected to NAO. Snow cover fraction is actually a driver of NAO at a lag of 1 month. Snow cover fraction drives the North Atlantic oscillation, which then actually influences the Indian summer monsoon rainfall at a lag of 2 months. This is one teleconnection pathway. Another teleconnection pathway is snow cover fraction influences the North Atlantic oscillation. Then North Atlantic oscillation influences the tropospheric temperature gradient at a lag of 3 months, which is then simultaneously related to the ISMR. Another teleconnection mechanism which is seen from this particular graph is that snow cover fraction can also directly influence the tropospheric temperature gradient at a lag of 3 months, which then simultaneously correlates with the ISMR. So these are possible teleconnection mechanisms, possible teleconnection pathways. So it is not one-to-one related to each other. There are several teleconnection mechanisms which are at play simultaneously. And in order to look at the map holistically, we have to actually do this kind of analysis where we can actually come up with the cause and effect relationship.
You have to conclude now.
Yes. The changes are there, or this changes relationship between the ISMR are investigated. This relationship is non-stationary. There is a lot of local variation between the snow cover fraction and the Indian summer monsoon rainfall. The correlation between the snow cover fraction and NAO, it has a small scale structure. It shows that small scale structure of SCF is a potential driver of large scale circulation changes by the NAO. Moving correlation and causality analysis, it shows that NAO influences the ISMR variability and thereby modulates the long-term ISMR derivation on a decadal time scale. And our result warrants for a review of classical concepts of teleconnection with the Indian monsoon through the surface temperature gradient. And if these sensibly applied causal inference mechanisms, they can go a long way. And using these kinds of schemes, we can actually come up with the teleconnection mechanisms in a better way. And the results are published here. Thank you very much.
Thank you, Dr. Sunil. Yes, sir.
I'm sorry, time was not actually my time.
Okay, let me ask you the physics of the problem. Why there is connection between Himalayan snow cover and monsoon? What is the physics? And if you try to understand the physics, then you can try to understand the changes, why it is all. Kindly explain to me what is the physics behind.
He is considering a European snow cover.
Sir, I am taking the Eurasian snow cover, not the Himalayan cover.
So that's okay. That's it.
So it is. I am telling you, it is. Yes, sir.
The one I remember is Himalayan snow.
Yes, sir. Himalayan.
And all those.
Correct, sir. Those things were there actually, sir.
Hello, Dr. Trivedi. One question only. When you are saying that the relation between Eurasian snow cover, ISMR is not at all stationary, it is varying, negative and positive, then how can you say that it is a useful predictor for IMSR now warming? Because correlation has to be stable over a long period of time. Then only there will be some use.
That statement is for recent decades.
Mm.
The recent decades.
But it keeps on changing.
Yes, sir. It keeps on changing, but in the last 20-30 years, it is highly positive. The correlation between them are as large as 0.7. This is what I am saying. So in recent decade, after 1980s, this correlation is becoming more and more important.
So you did not answer to my question.
Sir, I will answer your question. This is a long question.
Yeah, that we can discuss.
This is to surface temperature, tropospheric temperature change.
Excuse me, I have one question. So what is the pathway through which SCF influences TTG, the tropospheric gradient?
That
The physics.
That is what I have actually explained in this particular slide.
I want the pathway. What is the physical process which really...
So this is the North Atlantic oscillation. Yeah. North Atlantic oscillation, it modulates the tropospheric temperature gradient.
So what is the pathway, physics?
Pathway.
This is what I have. So snow cover fraction actually influences the North Atlantic oscillation. If you know about North Atlantic oscillation, then it is a large scale phenomena which actually varies on a climate scale. So, and that particular phenomena then influences the tropospheric temperature gradient. Okay. If you know the actual physics, then it cannot be summarized actually in this particular talk.
Yes. You will read my.
always there is lag, 1 month, 2 month, 3
Yes,
month.
yes,
That
yes.
means the monsoon is always related to the pre-monsoon.
Correct.
So that there is no relation between monsoon and post-monsoon?
So here, I'm not talking about monsoon. This is the JJS monsoon rainfall, and these months are taken. So snow cover fraction is taken 3 months earlier. So for February, March, April, or March, spring snow cover influences the following or JJS monsoon. That is what I am saying here.
So that I am asking. So that monsoon, if you see that post-monsoon,
I have not seen the effect on the post-monsoon season.
Okay, you have not
because
seen.
Some kind of hydrological feedback has to be involved. The snow cover fraction cannot sustain the entire JJS monsoon rainfall.
Okay. I think we
small scale phenomena which influences the large scale phenomena, which then sets in the that I have not seen.
Okay, we end with.
But if I means, to be very frank, the snow cover fraction, it cannot modulate the post monsoon October, or December, January, February, or September, October, February monsoon.
Good enough, Professor Sunit.
After
Later you can explain.
Yes.
Okay. Thank you very much. Thank you very much.
So this combined with hydrological feedback.
Okay.
Thank you very much.
We move to the next one from the same university, Allahabad University, same J.K. Banerjee Center, M.N. Saha Space Center.
Yes, sir.
And Dr. Shailendra Rai.
Yes.
He is going to speak role of Southern Indian Ocean in modulating Indian summer monsoon.
Good afternoon to all of you. First of all, I would like to thank the organizers for giving me the opportunity to present my work.
They are not here.
The topic of my talk is role of Southern Indian Ocean in modulating Indian summer monsoon. And the collaborator in this work is Dr. Namendra Kumar Sahi. He was my PhD student, but he is presently working in CMCC, Italy. It is a well-known fact that the tropical Indian Ocean modulates the Indian summer monsoon, and there is one mode of variability that is Indian Ocean Dipole. It was discovered in 1999, and it has been studied extensively. Many studies has been done to see the influence of Indian Ocean Dipole on Indian summer monsoon, but there is another mode of variability in the Southern Indian Ocean. It is called Southern Indian Ocean Subtropical Dipole. It was discovered in 2001. It is less explored. There are some studies which has been done to see the impact of Southern Indian Ocean to influence the anomalies over tropical Indian Ocean and so in Indian Australia summer monsoon. But influence of Southern Indian Ocean on Indian summer monsoon variability has been less explored. So for this work, I have used only SST data, had SST data from 1952 to 2013. And for atmospheric variables, I have used ANSEP-NCAR reanalysis from 1983 to 2013 at 2.5 degree by 2.5 degree resolution. And for to see the influence of these SST and over the land points of India, I have used Indian Meteorological Department gridded rainfall data at 25 kilometer by 25 kilometer resolution during 1952 to 2013. I have divided my talk in two parts. In first part, I have just analyzed the SST of Southern. I have computed EUF. I've divided the entire data set from 1952 to 2013 in two parts, from 1952 to 1982, and then from 1983 to 2013. This is the EOF result. We are seeing the clear dipole-like structure, which is very close to the dipole-like structure which was proposed by the work by in 2010, subtropical Indian Ocean dipole work. So based on this EOF pattern, we have computed some indices, subtropical SDI indices for two different seasons, DJF and MAF, and for MAM, March, April, May, and for two time domains, that is from 1952 to 1982 and 1983 to 2013. And these are the reasons. We have taken the area average of SST anomaly for these two regions and then taken differences to compute the indices. So when we regressed the rainfall only in the month of June, not all, I have not taken all the months, I have taken just June month. I have also analyzed other months, but in June months we have seen some differences. In June months, when we regressed the rainfall with respect to SDI DGF from 1952 to 82 and SDI MAM, we are not getting any relationship between these the June rainfall and SDI indices. But when we did in 1983-2013, we are getting some negative relationship in the month of June only. So to do it further, we computed the 30-year running correlation between SDI DGF and rainfall in the month of June. In the recent years, we are getting negative correlation coefficients, which was not there in earlier years. Then we did the composites of rainfall in the month of June for positive SDI in the month of DJF and negative SDI. And as we have observed in the regressed model, from 1983 to 2013, we are getting negative rainfall over entire India. And for negative SDI, we are getting positive rainfall. Similarly, for MAM season also, we are getting negative and positive. So this shows that there is a relationship between June rainfall and SDI indices. So to see that how physically it is possible, we have done the composites of winds in the month of June for negative SDI and positive SDI for both for DJF season. And in the negative SDI, we are getting some correlation, some circulation pattern there in southern Indian Ocean. And through Mascarene High, it is going towards the land points of India. So this may be one of the reasons that the rainfall is decreasing during, rainfall is increasing in negative SDI. And opposite is the case for positive SDI. The winds are going away from the land points of India. So this may be one of the reasons. There may be other reasons, but this is one of the reasons. This may be one of the reasons. So in first part, we can conclude that SDI of DJF and MAM, these are like 6 months duration. During 1983 to 2013, impact rainfall over India in the month of June only. It is physically, to see the physical pattern, we have also done the wind patterns, which favors the enhancement of rainfall during negative SDI, and opposite is the true for positive SDI. In second part, we have the time domain is same, but the region of analysis I have taken some entire from 60 degrees south to 60 degrees north. I have taken SST data, and in this I have taken JJS rainfall and did a correlation coefficient analysis from JJS rainfall and monthly SST anomalies for different months. And based on this correlation, we have taken some indices P1, P2, P3, P4, P5, P6 like this for these months. And these are the regions given in this table for these months, and these are indices, different indices. These are the spatial domain, and the correlation coefficient with ISMR. We are getting some for some indices it is negative, for some indices it is positive. So based on this, we have devised. We have made some simple multi-regression models, 5 models. Based on different combinations of predictors. So the correlation coefficients, the correlation coefficients from 1982 to 2001 training period and test period 2002 to 2013, we are getting high correlations for, especially for model 4 and 5, the predictions are good. This, we can see it from different models and MLR models for to predict ISMR rainfall, average rainfall all over India. Then to see it further how it is happening, we have done the regression maps of JJS precipitation anomalies onto these indices. So far, the indices in which we are getting negative relationships, we are getting negative rainfall regressed maps over India. And for the indices in which we are getting positive rainfall over land points of India. So this also clearly indicates that it is related. To do it further, we have computed regression maps of JJS winds anomalies onto these indices, and in these regressed map also we can see that for those indices in which we are getting negative relationship, the winds are coming out of the land points of India, and for those indices in which we are getting positive, the winds are going towards land points of India. Then we did the JJS seasonal anomaly composites of rainfall for positive years and for negative years. Similar is the case for positive years. Since P1 we were seeing the negative relationship, it is negative over land points of India for positive years, and for negative years it is positive. Similar is the case for other indices. Then I have seen the JJS seasonal anomaly composites of wind for positive years and for negative years. For positive years, since P1 was negative, the winds are going out of the land points of India, and for negative years, it is coming towards land points of India. So in this part, we can conclude that we identified 8 SST predictors based on the spatial pattern of correlation coefficient between ISMR and SST during 1982 to 2013, and we constructed different multilinear regression models, and we are seeing that the forecast skill is high to predict observed ISMR from these models, and we have also seen the robustness and physical mechanism of the observed teleconnections between SST predictor and ISMR by regressing the rainfall and wind corresponding to all the 8 SST predictors. Although this is a like a statistical type of work, so it requires state-of-the-art modeling experiments to verify these teleconnections. We can do it. So, thank you.
Thank you. Thank you. Yes, sir.
So, the first part is very interesting and that is very useful. You remember there is a book by Professor Krishnamurthy, Tropical Meteorology.
Yes.
I think he was the man who first started the importance of masquerade high.
Yes.
Yeah, that's what it
Yes.
is. That's very interesting.
Yes.
But you should go further into it. What I am
Yes.
saying is, don't leave there.
Okay.
Go further to understand what is the physical mechanism of it.
Yes.
For the other
Yeah.
parts also. Go deeper into that.
Okay, we are doing it, sir. We are doing this.
Thank you, Professor Rai.
Thank you.
So with this, we conclude one keynote address, 2 invited talks. Thanks to the speaker, and organizers want to give some token memento to the invited speakers and the keynote speaker.
Well, I would like to invite the keynote and the invited speakers onto the stage, and they would be felicitated by our chair. So first I would like to invite Dr. Ravi Shankar. Now I would like to invite Professor Sunit Dwivedi. Dr. Shailendra.
Okay? So this part is over. Now we have 2 more oral presentations, and you can go. 2 more oral presentations, 10 minutes each. The first one is Dr. Shubhi Agrawal. She is there? Yes. Please go ahead with your presentation. 10 minutes. If you want comments, you can finish in 8 minutes.
Hello everyone, I hope I am audible and visible. So good afternoon everyone. My topic for presentation today is precipitation biases in the East Asian monsoon and monsoon region and their association with circulation bias in the CMIP6 models. So the aim, and I would like to thank my collaborators here. So I am Shubhi Agrawal and my collaborators are Ruth, Dipanjan, Hugo and Jeff. All of them have contributed different parts of this presentation.
Which institute? You can say that.
I am from IISER Bhopal. I am assistant professor at IISER Bhopal. So the idea here was to understand Asian monsoon system at large and to understand how these different biases or the different precipitation systems within the Asian monsoon system are related to each other or affect each other. And the main focus was on East Asian monsoon because the project was funded by China. This is the JJ's climatology from GPCP precipitation and the winds are from JRA 55 reanalysis data sets. And what you see here is the large scale precipitation system, and this is our Asian monsoon domain. So the focus was East Asia. And in this study, what I have been focusing is how East Asian precipitation bias is related probably to Northwest Pacific precipitation domain. And also I wanted to understand how Indian monsoon is probably related with East Asian monsoon system. And I'll show some results here related to these. If we look at low-level circulation for this domain, focusing on Eastern Asia, then 2 main sources of moisture transport for this region is one, the Somali jet, which brings moisture from southwesterly direction. And apart from that, we have West-North Pacific subtropical high here, this circulation, which is responsible for a lot of moisture transport to the East Asian region. And this I'll be calling as WNPSH in subsequent slides. And the winds associated with this circulation, which are mostly southeasterly, they are responsible for a lot of southerly moisture transport to the East Asian region. these are two regions. I have demarcated this region into north and south because the precipitation variability here is, it has a dipole sort of structure, and during JJS they are out of phase or anti-correlated with some strength. So northern East Asia is 30 to 40, this box, and southern part is 20 to 30 north, and both these are within 110 to 120 east. So we wanted to back up our results, like before moving to model, completely model analysis, we wanted to see some signatures from observation which are more realistic and believable. So this part is contributed by the collaborator Dipanjan Dey, and what he has done is he has used ERA interim data for 20 years, and he has identified moisture sources for East Asia from different ocean basin domains. So Pacific Ocean domain, Southern Indian Ocean domain. So this will be mostly related to Somali jet, and Pacific is mostly related to the southeasterly associated with the subtropical high circulation. Then East Asia region in itself has large contribution from local recycling. So the local recycling component from South Asia and East Asia, and in blue you see the totals. So the most dominant part of precipitation, this is precipitation in Sodrup. So most dominant part you'll see is in green, which is the local recycling part. But the important characteristic that we observed here was the local contribution from EA, it is high, but it is not related to interannual variability of precipitation within, it's not as strongly related to precipitation variability in this domain as the oceanic sources, which can be seen in pink and black. And they do have some variability within April to September, which is quite large. And if you look at just the recycling component, it does have some variability, but it's rather small. So the same thing is quantified and showed at interannual time scale. So this is from 1999 to 2018. And in red, you see the total variability associated with precipitation, and the non-local contribution, which here we are trying to focus only on two non-local forces, which is from Pacific and the Indian Ocean, Southern Indian Ocean. This is quite large compared to the local contribution. And if we look closely, then the purple color from the Pacific, it shows larger contribution to East Asia precipitation variability compared to other ocean domains. So moving on from here to another observation based result. And this, what I am trying to show here is the correlation between or the association between different monsoon regions. And this is the Northeast Asia precipitation, like this box precipitation, mean precipitation JJS, is regressed with precipitation all over the globe. And in red, you see the regions which are positively related to Northern East Asia precipitation, which means they vary along with it and they have similar sort of interannual variability. And these two regions, Southern East Asia and Northwest Pacific region, they are out of phase with Northern East Asia region. Now these regions are important because they are closely related geographically, and precipitation distribution here is not independent of each other. So precipitation variability is related in these regions. So if we try to understand the variability together for these regions, we might be able to point out to one source of error or one source of like one dominant source of variability which affects precipitation distribution in these regions. And this has been like shown in some next slides. So now these are the CMIP6 results. So these are from CMIP6 models, historical simulations, which are the past runs, and the data here is from 1979 to 2015 onwards, and we have considered around 24 models which had reasonably regular data, and grid size and resolution was also a consideration here. So we have tried to include all the models with similar grid resolution and so on. And what you see here is the JJ's precipitation bias between models and observation from CMAP. So in blue you see positive anomalies, and in red you see the negative anomalies. And Asian monsoon domain, it has large precipitation biases. And in many of these models, you'll notice these three regions, North, West Pacific, and East Asia, North and South, they seem to have some dipole structure or out of phase relationship, and it comes across even visually in these models. So now looking at JJS evaporation, so we wanted to understand, for precipitation, we wanted to identify the main source of moisture. So in the evaporation biases, which is just evaporation from CMIP and JRA 55, so what we noted was the magnitude of evaporation biases across all these models is rather small, and most of the precipitation bias can be actually attributed to P minus E, which is sort of proxy for moisture convergence term. So it gave us some idea that the biases across these models is probably largely influenced by circulation biases and not so much by local recycling component. In this figure, what you see here is Z850 meter height contour in blue. So this is 1500 light blue and dark blue is 1510. And here you can get an idea about the subtropical high strength. So between all these models, you'll notice that the western edge of North-West Pacific subtropical high, it is located differently across these models. So there are biases across models in simulating the subtropical high strength and its westward extent, which can largely influence wind circulation and moisture transport in East Asia region. So from here we define the western edge of the western edge of this subtropical high circulation, and we found the longitude for each of these models, and that longitude and precipitation, they are plotted in these figures, and all the models are summarized here. So this is for northern East Asia, this is for southern East Asia, and this is for Northwest Pacific. And on the x-axis you see as the western edge of western North Pacific subtropical high in degree east. And what is amazing here is that we can clearly see there is a correlation, negative correlation between northeastern subtropical high. So the more it is westward, so more shifted towards westward, which is like more towards the East Asian, the more it is shifted to the westward or closer to the East Asia continent, higher is the precipitation in the northern part of East Asia, and lower precipitation is seen in southern part of East Asia and Northwest Pacific Ocean. So this is what is summarized here. The negative correlation is because the westward shift is a negative quantity, so you'll see negative correlation. And all these models, they show a nice correlation, and especially this relationship is strong, or the influence of western subtropical high is strong for northern and West Pacific region, and not so much over southern East Asia. Probably we also compared southern East Asia like between AMIP and coupled model, and we found that for southern East Asia the variability could be coming from oceanic processes and so on. So in short, what happens is basically with a westward shift in western North Pacific subtropical high, the southerly component of the winds increases for northern and southern East Asia both, and it causes a lot of moisture convergence mostly in the northern East Asia part, and slightly lesser in southern East Asia part. We also investigated the relationship between fin letter jet, so the moisture transport. This last slide. So this was to understand the relationship between Indian monsoon and East Asia, and across the models we didn't find any strong correlation between strength of jet and East Asian monsoon precipitation, and this could be due to multiple reasons. This is not pointing at lack of physical relationship, but it could be also just there are large biases in simulating fin letter jet across these models, and large low level wind biases. So with this, I think I'll wrap up, and thank you.
Thank you, Dr. Shubhi. Yes? You don't need anyway, Mike, you don't need.
I don't need it. How did you know Ruth Jean? You went to Caltech?
So I was doing my postdoc at University of Exeter. I was doing my postdoc at University of Exeter before joining IISER Bhopal. So I was there last year.
Yeah, but she did a lot of very important
Yeah.
There
She.
is a review search you read the paper?
Yes.
That's a wonderful
Yeah, I am
post.
heavily impressed by her work. Yeah.
Very good,
Yeah.
very good.
Thank you.
Thank you, Dr. Suvi. Thank you. So the last one is Mr. Sumit Mukherjee. Yeah, please come. Unprecedented rainfall intensification over Western India during 2019 summer monsoon.
Hello.
Pointer. ये पॉकेट में डाल सकता हूँ ये हेलो It's working? It's not working. This one, I'll use this one. Hello everyone, I am Sumit Kumar Mukherjee. I am from IITM. Sorry.
Mike. Yes.
Okay. Hello everyone, I am Sumit Kumar Mukherjee. I am from Indian Institute of Tropical Meteorology, Pune. Today I am going to present my recent research work, the unprecedented rainfall intensification over Western India during the 2019 summer monsoon season. Over the past few decades, the Central Indian region and mostly the whole of the Western Indian region is experiencing the decreasing trend in mean monsoonal rainfall, whereas the extreme rainfall events are on the rise. But in case of Western India, mostly in the Maharashtra, coastal Maharashtra and Gujarat region, it shows the increasing trend in mean monsoon and extreme rainfall. In both cases, we can see the increasing trend, which has been studied by these authors. Okay. So now, why are we investigating the 2019 summer monsoon? What is special about this season? So this 2019 monsoon season was the strongest monsoon year since last 25 years, since the 1994. So in this year, AIMR, that is the All India Monsoon Rainfall, received 110% of long period average rainfall as a whole, and most of the meteorological subdivisions in Western Peninsula and the western part of Central India recorded rainfall greater than 20% of the seasonal climatology. One striking feature of this season is that the prevalence of exceptional heavy rainfall events like floods and extreme rainfall events and landslides over the western part of the country and the west coast. Interestingly, an extreme positive IOD event developed during the summer monsoon of 2019. So we will try to connect these heavy rainfall events with the positive IOD in our next course of talk. Indian Ocean dipole is a significant mode of natural climate variability in the tropical Indian Ocean, and IOD can modulate the extreme rainfall activity over India by influencing the cross-equatorial moisture transport. In this figure by Ajay and Rao, they have shown that in the central Indian region of Ganga Mahanadi basin, the extreme rainfall events are negatively and highly negatively correlated to the sea surface temperature anomaly near the Java Sumatra coast. This is the cold pole of IOD. And also in 2011, Krishnan et al. Showed that the LPS related rainfall gets increased over the whole east-west section of the central India and western India during the positive IRD years. Okay. Based on this, we framed our science objective as understanding the coupled large-scale ocean atmospheric conditions favorable for development of organized convective systems, in which led to persistent heavy precipitation over Western India during the 2019 summer monsoon. These are the data sets we used during the course of this study. First, we studied the interannual time series of JJ's dipole mode index, which is the indicator of the strength of Indian Ocean dipole, and the JJ's rainfall anomaly over Western India. So from this figure, we can see that the intense positive IRD events, mostly the intense ones, those are associated with the high rainfall anomaly over Western India. This is the box of Western India we chose for our study. The most striking feature of this plot is that the year of 2019, in this summer, the highest rainfall anomaly over Western India and the highest DMI occurred at the same time. Okay, so this is the plot of the seasonal outlook of the 2019 monsoon, and from this plot we can see that an extreme positive Indian Ocean dipole was developing in the equatorial Indian Ocean, and also from the middle level 600 HP picture, we can see that one anomalous cyclonic circulation was there sitting over the northern Arabian Sea throughout the season. Next, we studied the subseasonal time series of normalized counts of normalized station count of heavy rainfall incidences, heavy to extreme rainfall incidences. These are the categories in this plot. This is for the heavy rainfall, this is for the extremely heavy rainfall, very heavy, and this one is for extremely heavy rainfall. So we can see here that this 2019 monsoon season had 3 distinct intense rainfall episodes, which we call the IREs. And these IREs were 28 June to 12 July, 24 July to 11th August, and 1st September to 14th September. For this study, we chose the threshold of 5% of stations, 5% of the number of stations that reported the rainfall on a particular day greater than 64.5 millimeter. That is the heavy rainfall category defined by India Meteorological Department. And the initiation and termination of IREs were defined as the consecutive 5 days above threshold and below threshold respectively. Okay. Next, we looked at the Wheeler anomalies, which is indicative of the organized convection. We found that the northward propagating Wheeler anomalies and northward propagating Wheeler anomalies just before the intense rainfall episodes, which we can see from these 2 plots if we compare. And also those extreme those rainfall those Wheeler anomalies persisted during the IREs. So vertical profiles of latent heating is a very is a good instrument to look at the intense rainfall episodes. So vertical profile can be classified into 2 categories broadly: the convective and stratiform. The convective profile has a single mid-tropospheric heating peak, whereas the stratiform profile has upper level heating and lower level cooling. So, climatologically, Western Ghat and Western India is a Western Ghat, mostly the windward side of the Western Ghat. It is a region of shallow convection. And from this figure, Sige et al., Sige and Kumero 2016, they showed that this region, which is the windward side of the Western Ghat, this is a region of shallow convection, and though the deep convective clouds can be seen over the Bay of Bengal region. Also, the stratiform precipitating deep clouds has been seen, observed over Indian West Coast region during monsoon season, which has been studied by these authors. Next, if we look at the GPM DPR surface rainfall estimates and the SLH latent heating profile from the GPM satellite, we can find that the surface rainfall, which is the left panel, and the stratiform rain fraction, which is the right panel, the surface rainfall is mostly contributed by stratiform rainfall. And this right figure shows the vertical profile of latent heating from the SLH data. And here we can see that the heating from here the black line shows the mean heating of the selected days, mean heating profile for the selected days during the IISER. So this from the mean profile we can see that there is a maxima at the middle level, middle to upper level, nearly at 400 HPA, and there is a secondary maxima at the lower level which come from the convective heating. But the most important thing is the upper level maxima, which is basically from the top heavy heating, and this is the indicative of abundant stratiform precipitation during the IREs. Next, we studied the regression patterns of 2019 JJS daily time series of heavy rainfall, which I showed earlier, that bar plot. And we regressed that time series over these quantities like vorticity, relative vorticity, circulation, potential vorticity, omega, etc. And if we look at the vorticity, mid-level vorticity, 650 to 500 h per relative vorticity, and circulation, we can see that there was an extended band of east-west extended band of relative vorticity and cyclonic circulation over the Indian subcontinent. It was also extending towards the South China Sea. And along with it, also we studied that the 330K PV was also very high over this region. And the interesting thing is that during this IREs, the maxima was over the Western Indian region. This high mid-level PV from this plot we can see that high mid-level PV sets the environment for deep convection, which is evident from the strong ascent at mid-level. Next we can establish the linkage between IOD and deep convection in 2019 season as follows. The positive IOD conditions that were developing during the JJS season, it enhanced the cross-equatorial moisture transport, and it depleted moisture from equatorial Indian Ocean and accumulated it towards the Indian subcontinent. It led to significant moisture convergence and organized convection over the extensive regions of South and Southeast Asia, and this resulted in the intense rainfall episodes. But one noticeable thing is that these intense rainfall episodes were not isolated. Those were not the events that were confined over the Western India alone, but those have continental span throughout the South and Southeast Asia.
Conclude.
Okay.
Okay.
Now we can summarize our result like this. Using the ground-based and satellite observations and reanalysis data sets, this study unraveled the large-scale ocean-atmospheric interconnections with the organization of convective systems over Western India in 2019 that caused the wettest monsoon over Maharashtra and Gujarat since 1901. This study highlights the impact of strong positive Indian Ocean dipole conditions on stratiform precipitating systems over South Asian monsoon region. And lastly, considering the recurring monsoonal flood-producing heavy to extreme rain events over Western Indian region in the recent years, this study provides a reliable framework for the heavy rainfall outlook suitable for this region. Thank you for your kind attention.
Thank you, Sunit.
Okay.
Any question?
Only one.
Yes, yes.
Sure.
Yeah, as you said, the northern propagation was very active.
Yes, sir.
But why it was confined to only the western side, not eastern side?
You mean the rainfall, heavy rainfall incidence?
Northward propagation was uniform.
Yeah, yeah.
You have taken the
No,
average from
actually, it was not that much uniform, northward propagation.
But you have not shown the distinction between western
I'll
and
show
eastern
you.
side.
Yes, sir. I'll show you.
The
Yeah,
average
this one,
was
right?
60 to 100 degree, 65 to 100 means
Yeah.
covering both.
Yeah.
But
covering the
only
most.
western part was more rainfall. Eastern part was not that much. So my
No,
point
the
is whether
rainfall
there
was
is-
also high in the eastern part. Comparatively, Western India was, the extreme condition was over Western India. Rainfall was high. If you are talking about the northern part of the region, India, that was, yeah.
Anything else? No. So with this, we come to the end of the session. Thanks to all the speakers, as well as to organizers for giving me this opportunity. Thank you very much.
Thank you, sir. You can all proceed for lunch, and the next session would be starting at 2:30, and that would be sustaining green life energy, session on energy. Thank you.
Just a moment. Let me just freeze the screen. Where is it? Adobe.
तुम अपना ओपन करके रखो ना, गेस्ट एज अ गेस्ट।
मेरा भी ओपन है, कुछ मेल कर
हाँ मैं कर देता आपको।
हाँ तो ओपन ही होगा ना, दिक्कत तो नहीं है।
ये ओपन ही है, कुछ करना हो तो कर लो।
अभी
सारे इंडस्ट्री वाले आ गए हैं क्या? आदिल खान सारे इंडस्ट्री वाले आ गए? एक ही तो आया है जब से।
अभी एक डेस्कटॉप के फोल्डर है ट्रॉपमेट के नाम से, जो इसमें ओपन है सब। अच्छा, ये फोल्डर मतलब